Ladies and gentlemen, thanks for coming and happy to see you all here. I would just like, before we officially kick off with the Technical Forum, to ask Götz-Ulf Jung-Michel for an official opening of the 20th Technical Forum. Götz, please.
Good morning and a warm welcome here in Berlin. My name is Götz-Ulf Jung-Michel. I'm the new Managing Director of the World Money Fair. It's a great honor and pleasure to have you all here with such competence, as I am new to the industry. I know how to run shows, and I'm learning quite a lot, and quickly, I hope, so that I can catch up. When I grew up, I was a child, and I always watched. We have a television and educational program in Germany called the TV Show with a Mouse. And the mouse always explained issues, like how do the stripes get in the toothpaste and stuff like that, how are tennis balls made. So my technical feeling was awakened very early. And what I have seen so far and what I have understood, how coins and metals are made and the new possibilities, I find it very, very interesting. And that's the fun part for me in running the shows, where we have three worlds to combine. We have the collectors, we have the national mints and the banks, and we have you from the technical side. And that, for me, really makes this show to be a world-leading show. We're trying to set standards. We are up in the relaunch as well. Here in the Technical Forum, you can see we have new designs and everything. So I hope that you get the most out of information that you're hoping for and that you need it. And before you start, I need to ask Anja to please come over, because it is the 20th Technical Forum, and we have two guys here who have been running it from the very first moment. We did take some time to get used to each other, but I think it turned out in a great, great cooperation, and I'm really happy that you guys are doing it. And I know you didn't want any presents, but I know you've been away very often this year, and you did have to put some time, extra time in order to organize this, especially over the Christmas time, and that is why we have two little packages for you. And your wives. You better find the right weekend in order to take a weekend off and enjoy anywhere you like with these little packages. Okay. Thank you very much.
Thanks a lot. Thank you.
And as a symbolic prize for all of you tonight, the first round of drinks is on us.
Yes, thank you.
Enjoy your Technical Forum, whereas I take care of our little technical problems we still have at the entrance. We will have that solved by tomorrow. Wish you all the best. Thank you very much for your attention. The floor is yours.
Thank you. Thank you very much for this nice and very kind opening, and a promise we will not take until tomorrow morning with the Technical Forum. And still hope that the guys which are still on the road will meet us pretty soon. So from us, Thomas and myself, of course, a very warm welcome to all of you. We are really happy to see you all. We had some issues, of course. Airplanes were not starting today in some areas because of strike, and local transport is also a little bit interrupted within this town and within this city. But anyway, you made it, and we are happy to see you all here on the 20th Technical Forum. We have prepared for you 15 papers. We have 11 themed blocks, as you can see it right here. We have a full loaded program, and we need you, of course, to participate for some very good reasons, which I will come back later to you.
Hello, everybody. The procedure to come to this event every year is almost the same. There's a call for papers, which starts to everybody who has been here, but definitely also to those who are willed to also do some presentations and show their innovations. This year was very special. We had more than 12 presentations to be chosen, because we had 22 people trying to apply for a presentation. And at this stage, I would specifically thank the Kazakhstan Mint, Economa, GF Solutions, and Schuler for not presenting, because it would have just taken too much time. This is something we typically do not say, but we heavily invite you to be part of the show next year. We have 15 presentations, and we are going through different technologies where we have discussions about sustainability. Xinyao will be the first one looking into this. Tool making laser, coin design, tooling laser, inspection, security, coin blanks, PVD coating, refinery casting, coin plating, commemorative coin production. So you will see 3 blocks, about 5 presentations. After that, we will have a break, and you can discuss as much as you want, and you will be back on time, hopefully.
There are some do's and don'ts, and of course we would ask all the presenters to stay on time. We have blocks of about 12 minutes. We have some changes this time in the presentations that we will excite the audience with teasers, which you might have seen in the social media, but again, we have that just before to warm the topic up. Questions are allowed, of course, before the break. Before the break, we will have time for Q&A sessions. We will make videos for the whole technical forum, and the videos later could be seen for everybody who has access to the tickets very, very early after this event today and streamed on the website. In addition, of course, we would ask you, the audience, to respect the presenters in a way that you put your cell phones in silent mode, but you need your cell phones later. I come back to that pretty soon. And you do the discussions, of course, you have in the networking time during the breaks or later during the get-together. You will have time and many surprises during that period, especially at the get-together, but for that a little bit later. Doing that one. This is an important slide for everybody of you, and now I ask you to pick up your cell phones and have a close look via your cell phone to this barcode, because here you come then to the Q&A side. We really ask you to participate actively in this technical forum. You can write the questions you have for the presenters straight in this Slido tool. And you can do this anonymous, but it would help Thomas and myself not to guess who asked these questions if you are friendly enough and just mention your name. But important thing is that for an active Q&A session, we have all your support and you asking the questions. And you can do that anytime during the first block. Just make sure that you don't forget what you wanted to ask, and you can write down the questions immediately. So if you have that on your cell phone, you have access to the Slido tool, and Thomas and myself will have then the questions. You can make life a little bit more difficult for the two of us if you like the questions. You can push them upwards. If you're just reading one of the questions and the other question is popping up, it will confuse us a little bit, but do not hesitate. Just push up the questions if you want, because this shows that this question is more interesting and more liked, and that if we have a time limit for the Q&A session of about 15 minutes, then we have the most interesting topics being asked then to the presenters.
Julia, can we have the first teaser, please? You've seen the first block, and the first block will be started with the super spot, and that is presented by Dr. Xinyao Li. Xinyao, will you please come up to stage? The topic recycling and manufacturing green, sustainable, also in the precious metal area. Zhenyao, you will tell us about the developments you have been doing at the Royal Canadian Mint and the latest statutes. Thank you very much.
Thank you, Thomas. Thank you, everyone, for your time to come to a technical forum, and I'm pretty happy to be the first one to present. I hope you won't be disappointed. I know the first session is titled as the sustainability. So clean technology and sustainability have become very important topic in our industry. As you, many of you actually witnessed at MDC conference 2023 in Ottawa last October, and a lot of sustainability topics presented here, discussed there, and of course, I'm quite happy here to talk about what the RCM has been doing. So my presentation today is breakthrough innovation at the Royal Canadian Mint. So first of all, I want to talk about quickly the updates on the clean technology and clean manufacturing in one of our facility in Winnipeg. So non-side bronze plating. And then I will focus on the gold refinery in our another facility in Ottawa. So overall, I will share the story, what the green and clean technologies and manufacturing at the Royal Canadian Mint. So as you have heard when you were in Ottawa October last year, RCM has a solid foundation in place to promote and lead the environment, social, and governance, or ESG. As we pursue our ESG journey, we have many opportunities to create for our customers, to add the value for our customers by minting for the future and minting with care. So this slide actually shows you the opportunities that we have identified for both Ottawa and Winnipeg, and also what we care for our customers. So among those opportunities, two of them are the topics of my presentation today. First one is about the plating technology. Second one is about the reduction of chemical use in our gold refinery. Of course, I mentioned first to give you updates about our non-signed bronze plating process for circulation coins. As we all know, circulation coins have many materials or many structures for circulation coins, and yellow color or color as the wonderful components of circulation coins is quite popular. So brass plating or bronze plating have been used for circulation coins, even for bimetal coins or even trimetal coins, and they're quite popular. But traditionally, the bronze plating is being done by using cyanide chemistry. As we all know, cyanide is very toxic and dangerous chemicals. It's not good for employees' health. It's not for our environment. So at the Royal Canadian Mint, we have developed our own formula by using non-cyanide plating process. So we come up with our own solution for the plating. We have also come up with a solution for the wastewater treatment. Overall, this non-cyanide bronze technology is a very friendly, environmental friendly process. We have scaled up our process and also produce products for our customers. In terms of bronze specifications, we have different specifications, including red bronze and yellow bronze. So this is already been in our manufacturing facility in Winnipeg. So the main features of non-cyanide bronze plating are homogeneous and dense plating structure directly on top of a steel substrate. This non-cyanide bronze plating has a very superior coinability and durability and good performance because of the better and higher hardness and wear resistance as compared to other traditional plated materials. And this plating has also a superior adhesion and wear resistance as compared to other plated materials. And we're quite happy to see this new product being in circulation environment. So, and this slide just give you a few to see this green structure and also the mechanical properties. But next few slides, I actually like to talk about the more fun stuff RCM has been doing last 3-4 years. This is a mechanical gold refining process. I'm sure you will be wondering what will be the chemical process for gold refinery to take pure gold from gold doré things. So, and I will talk about the stories in next few slides. So this slide give you some just a general idea how the gold from the incoming gold doré, and become a fine gold. So the key things here by using traditional process is by high temperature and high toxical and chemical reactions to separate pure gold from the impurities. That's the normal process we have been seeing in industry. So in this process, the mineral chloration is the key, and this mineral process has been used for over 150 years. So what does mean mineral chloration process? That means that the incoming gold with the impurities are melted in a pot with the high temperature, 1,000, 1,100 degrees Celsius. You introduce the chlorine gas into the molten metal. So the chlorine gas would oxidize the impurities, and then you skim off the impurities from gold. So you get the higher fine gold, which is not high enough, make it as the anode for a subsequent electrolysis process. And then from the electrolysis process, you get the fine gold, either 4-line or 5-line. So that's the process we have been doing for now. So as you can see, the chlorine gas is the major oxidizer in this chlorination process. So it's very toxic and high energy and high temperature. We want to improve that. So last few years, RCM has implemented the so-called acid separation process to reduce the use of chlorine gas. So this is a vacuum technology where you don't have to use any chemicals, but you can separate some of impurities from the gold and then get a higher fine gold. But the objective of get rid of chlorine gas is only halfway through. That's not enough. So by this process, we only be able to get a 55% reduction of use of chlorine gas. So, and then our engineers scratched their heads, what else we can do? Starting the pandemic, actually just last 3-4 years, we have been doing something dramatic. That's something I'd like to share with you primarily today. So this is a chemical gold refining process. Now think about the chemical, and you may ask, what does it mean, right? So I will explain to you. But initially we explored this process in a special tumbler. It's kind of like just a ball milling. So in which, in this tumbler, you have the impure gold as the material. You also have some oxidants in the material and the stainless steel bore. Almost similar like my friend Thomas is doing in surface finishing. But of course, it's not exactly the same. The speed is much higher. The bombardment between the materials and also the stainless balls with the chemical reactants are much intensive. So you actually can make the gold or impurities oxidized in this process. So it's different from the burnish process, but the ideas in terms of mechanical force and some of the chemical reactions are kind of similar. But of course, the drawback in this process is that you have a foreign material, which is the stainless steel. Now we're looking for high purity for gold, right? So through many experiment trials, we have come up by this mechanochemical process by using acoustic energy. So that means that in the process we have developed, there's no foreign bodies. Stainless steel balls is not there anymore. So that's why it's different from our British process. So you may ask, what exactly mechanochemical chemistry means? So what is the mechanochemistry? And the terminology itself can give you the basically speak for it itself. It is a combined effect of mechanical reaction and the chemical reaction. So sounds very simple. If I use a quick story, right? So 10,000 years ago, our ancestor already started this mechanical invention. So we look at this, what a cartoon, picture, right? So our ancestor actually start to use, simple, wood stick, rapidly, turning against the stone, and then fire starts. In my view, that was the first human mechanochemical invention. But nowadays, the mechanochemical chemistry is actually a chemical synthesis or extraction by a mechanical force. The thermodynamic and the kinetic effects caused by collision between molecules is the driving force for chemical reactions that normally can only happen at a very high temperature and with very toxic chemicals. Can happen at a low temperature, even room temperature, without using toxic chemicals. Mild chemicals can do the same thing that the high temperature or toxic chemical can do. This is something we have come up in our gold refinery. So this is also main reason and the inspiration of rediscovery of mechanochemistry. Our ancestor, 10,000, 15,000 years ago, primitive friction fire get used in modern time. So, but the purpose is different because we try to say we can use lower temperature, low energy, and clean chemicals for our process. When it comes to the gold refining, as I mentioned earlier, so we don't want to any foreign materials, foreign particles to be part of the mechanochemical process. That's why we have shifted the driving force, mechanical driving force, from ball milling to acoustic energy. This is something we have come up with our academic partner, McGill University, since beginning of 2020. So basically, coincidentally with the pandemic period. So we have come up with this process. We have breakthrough some major milestones, and we have already taken 4-line gold from this low temperature and mild chemical reaction process. So if you look at the specific process, so incoming material, which is a gold doré, we use this material and transfer the regular format, big ingots into grains. The granulation process is a kind of standard process in our gold refinery. So we put this gold grains with the impurities, with the special oxidants we have identified, into a reaction chamber. And then you apply acoustic energy. You create this special mechanochemical reaction. So the impurities will be oxidized, and you separate the impurities and gold, and we also transfer solid gold into liquid gold. And the liquid gold will be going to our electronics process, which we're doing on a regular basis, for years. So this is how we combine the acoustic mechanochemical process with our electrolysis to form our new clean technology for gold refinery. So we're quite happy, the collaboration between the Royal Canadian Mint and McGill University. So as I mentioned earlier, we have come up, major milestones in terms of mechanical, hurdles, and also scientific hurdles. So this slide shows you the gold dissolution chemistry, how this acoustic mechanochemical process are happening. Simply say the impure gold react with mild chemicals, which is a salt. And I'm pretty sure some of us here may have used this kind of salt at your home. So that means that it's easy to handle. There's no kind of a dangerous or any toxic situations. And with this acoustic energy, we create this chemical reaction or extraction. So the data here shows how we can compare the reaction rate with the traditional aqua regia process. As you can see, the dissolution rate is very comparable with the high toxic chemical process. If we increase the temperature slightly, our reaction rate is even better than the aqua regia process. So this is a really, really exciting technology breakthrough. Even from scientific point of view, there's something we are quite proud that we break through something not only our industry, but also in scientific communities. So this slide gives you just a quick view, what will be the major steps of this process. At the beginning, we have this impure gold grains and also the salts. You can see the white stuff is just some special salts. Unfortunately, I won't be able to tell you. It's what exactly the chemistry of the salt, but it's a very, very, I would say, it's commercially available, salts that you can find, yeah. So once you put into this acoustic chamber, generate, these acoustic vibrations at the very, very high speed. We talk about the, 30G, 50G speed. And then you create this kind of a bombardment, localized, chemical reactions. So I can quickly show you this. You can see solid gold and also salts. At just few minutes, the solid gold will be transferred into liquid, and then go into our, electrolysis process. And eventually, should I go back a little bit? Can I go back? Eventually, we got the gold powder from this overall process. The purity is 4.9. So this is the process. No room temperature and salts as the reactants. But major difference, this is the acoustic vibration or bombardment. So, can I go back? So if you look at the slides I showed earlier, so in this process, we're going to use this mechanochemical process to replace the traditional mineral chlorination. This is a new process, so we're on the way to implement it in our gold refinery. As the conclusion, Royal Canadian Mint has produced the bronze plating for circulation coins, and also we've come up a clean technology of mechanochemical gold refining process. The patent pending technology has some breakthrough features. A few keywords, no toxic chemicals, no high temperature, no high energy needed, and the wastewater treatment is also very mild, and the efficiency is comparable with the traditional chemical process, and overall this solution is very environment friendly and user friendly. So I'm quite excited with this process, and also I feel very honored to share the stories with you today. Thank you.
Shenyao, thanks a lot. And thanking you for giving Shenyao an acoustic energy and for his presentation. And the first question you might ask, Shenyao, can we do this at home in room temperature? But if this is not your first question, you might ask another one. So please use Slido, use your mobiles in starting the discussions later for the Q&A session, which we will have just before the break. This is again the barcode which you can use. And Julia, can we have just the next teaser, because we want to introduce the next presentation. Thank you. Yeah, ladies and gentlemen, if we introduce the speakers for this presentation, which is Christoph Übelbacher from the Bavarian Statement. Thanks, Christoph, for coming over and supporting Roman Weidelich from InnoCode, a project we're talking about new approaches on reusing dies, talking about decoding, repolishing, and recoding. Also under the topic sustainability, which is more and more important also for us in the minting industry. Gentlemen, the floor is yours.
Hello everyone, my name is Christoph. As Dieter mentioned, I'm from the Bavarian Statement, and I'm very pleased to have the opportunity to speak here. At the last technical forum, during the presentation by Axis, I had this idea: why can't we just remove the PVD layer of the coated dies through laser and use them again? Afterwards, I told Romain about this, and he said, no one ever came up with this idea before. Thus, I have to say, he got so hell-bent to pursue the topic further. On that note, Romain, please keep going and show us the result.
Thank you, Christoph. Yeah, so thank you, Christoph, for the short introduction. So my name is Roman Weidelich. I'm the founder and the owner from InnoCode. I think most of you knows me already. Since a lot of years, I'm active in the minting industry. So this was a very interesting discussion we had last year during the technical forum. And we come out with this idea why we don't just use a laser not only for engraving, but also for the decoding of the dies. And after that, we started actually a long development around PVD coating and around die production. So on the first slide, you will get a fast overview about what we will speak today. First topic will be the coating itself. What is the outcome of the coating. Then we will have a look on the decoding. Then we will look on the recoating, on the repolishing and the recoating. And then we will speak about how to apply this also on other dies than circulation dies. So I think PVD coating, I don't need to tell you too much about it. A lot of mints are using already PVD. We can make chromium-based coating, titanium-based coating, or whatever. The aim is actually, at the end of the day, is that you have no formation of chrome-6 during the process. This is also the reason why it's seen as an environmental friendly solution. Another aspect, it's very simple to incorporate in a production facility. You don't need to take care of chemicals, etc., etc. What we could see in the last years, I've made a lot of presentation already about the topic, is the big differences between the performance of the dies, depending of the mills, depending of the die designs, etc., and also depending of the approach how to produce the dies. But this we will speak a little bit later. We had tremendous results in Croatia during the Euro introduction, where we could see that they were able to produce a whole volume with 290 dies, which is a very low amount of dies when you are thinking how much coins they had to produce. So let's go a little bit into the topic. So as every coating, sometimes you can have an issue, it can fail. You can have also defects within the die material itself. You can have defects which are just happening because of wrong processing in a machine, or problem with blanks or whatever. So what we can see here is actually a real Euro die which has a defect. So a first step what we have done was a cleaning of the die, and after that we were able to decode the coating by classical laser processing. So we were using a standard axis laser which was available in that case, and we were able to take the coating out in very short time. So we make some analysis on different kind of coatings. For example, here we make a test. We applied a coating which was not good in this case. We made it by purpose. And you can see on the left side, so the coated area, on the right side, the decoated area. And we made an analysis on a scanning electron microscope and some additional analysis to be sure that the coating is really completely removed. We have done this with the help of the University of Minho in Portugal, who was doing actually the analysis. So here you have a chrome-based coating. I just show you another one, just that you see it working everywhere. So here we have a titanium-based coating, for example. And due that we were so happy that it was working so simply, we started to discuss a little bit with Axis, okay, but removing is one thing, let's try also to rework a little bit the surface. And as you can see, we were using the pulse forging to also smooth up a little bit the surface and to reduce the polishing time. So after the decoating, you have a rough surface, and standard next step is a repolishing. So what are the possibilities? Possibilities is the standard hand polishing, but then you also have the machine polishing, which I will explain a little bit more about in the next slides. And then we have the pulse forging, which is already reworking a little bit the surface, but it's not enough actually. You still need to repolish when you want to have a mirror surface. So that's a combination. So what are the results? We are very happy to have been able to prove that it is possible to repolish dies by machining, actually. So the die which you are looking at the top has been repolished in Croatia, the Croatian Mint, on a Spalek machine. It's actually the die which you were seeing before. So you can see the surface is perfect, just ready to be coated again. Polishing time was less than 5 minutes. And the big advantage about this is we can assure a repeatability of the quality of the surface, whoever is polishing it. And as you know, polishing is always a big topic, depending of the way how you are polishing, depending of the operator, actually, of the person which is polishing, you can have a lot of different results. So I also spoke to Rösler because I wanted to also show what is available on the market, and they also told us, yeah, we are also doing it in Spain, and they provided us a picture so we can see both suppliers have a possibility to supply a solution, and it's up to them then to explain you more the details. After the polishing, nothing else to do. We just do the recoating, and I could be finished with my presentation. So we will summarize the aspect on the circulation coins. We have a process which is now completely in machine hands, so we are able to have repeatable results. We can rework the dies very simply by existing machineries. Most of you have laser machines, and we can use this process a lot of times. So what can we say? Here we can put a mark because it's working. Yeah, we know in Croatia they have implemented this process, and they are happy with it, and it's working, and they can just do it. I think we never reworked a die in so short time to be ready for production. Let's go to the next step. I think circulation is under control. Problem is sometimes the proof coin. When you are thinking of a proof die, it's always a mixture of different variables. So one of it's the die material, the way how you are engraving it, then the defect-free surface, reason to be proof, optimized polishing to have a good surface, and at the end of the day, a PVD coating, which is also giving a benefit for the die life and also supporting to keep the die shiny. What's happening with conventional hand polishing is, depending on the die material you have, that you can have a very high porosity in the material. This porosity can be a problem. Why? When you are polishing it by hand, you can have a super surface, but it can be that you just closed potential pores. So the pores are still there. So I made a slide because sometimes when people were still using galvanic chrome plating, they were asking me, we don't understand. Now we have a different surface after the plating, but the die was perfect, etc., etc. So what's happening is actually that when you are doing a PVD coating, the first step is normally plasma activation or plasma etching, where you have to take out all the oxides which are on top of the coating to make sure that you can have a good adhesion. It can happen, depending on the material, depending on your etching process, that closed pores are getting open again. And then you can have the situation, actually, that the super surface is not so super anymore. But this is not related to the PVD coating itself. It is really related to the way how the die material is, how it has been produced, which batch it is. It can be you have a super batch, super situation. You get the next batch of die material, same steel, but it's behaving differently. So you have to adapt your way of your polishing and make sure that you don't have these issues. So, knowing this problem, I was again speaking with our friends from Spalek and from Rösler to say, hey, now we can see it in circulation coins, we have a solution which works, which seems to be viable. Let's start to work on it on proof dies, or especially on mirrored surfaces. So what we have done, we took dies which were mirror polished, we decoded them to have a rough structure, and we analyzed it. So what we could see when we were analyzing is that we had a kind of leather skin structure, and also that we could see a lot of pores, actually, from the die material. So we said, okay, let's make a machine polishing. First of all, to have a good roughness, but also by the machine polishing, we are not closing pores because we are not actually pushing material inside the open pore, so we are really taking material away. And we could see that, yes, roughness is good, but we have still some work to do because every time that we were eliminating a pore, we were opening another one. So the status that we have today is this one. We can see that we can have a good surface, we can have a rough a very polished surface, but we still have problems with the pores. So it's, for us, means that we have to have a closer look on the materials itself and to work also with the steel manufacturers to define which could be the right materials which would support us to make it possible to eliminate this problem. We made the same trials with Rösler. You can see it also on these images. Same results, doesn't change. We always find pores. So then we say, let's take a real die. So we take a real die, and we say we go to the maximum extent, so even polishing the design away. And also here you can see you have a super mirror polish, so it's proven that we can do, by this kind of machine polishing, a super surface. But, again, we have the problem with the pores. So, to end my presentation, we want to work on a vision where we first of all classify what is the perfect surface finish, in working it by machine polishing and not by hand polishing to eliminate the problem of the human, which is not consistent, which is normal, that we are sure repeatable results, and at the end of the day we find the perfect combination of dye material, engraving, polishing and PVD coating to have the best result possible. I am sure that this will not be very fast and very easy, because at the end of the day, as I mentioned, there are a lot of topics on this. You can have one very good batch of dye materials, the next one can be bad, and then you have to rethink your process. But globally, I think what I also want to show with this presentation is what gets in, gets out. If the surface is not perfect for the technology, for the PVD technology will not make it better. And this is, I think, something which is also quite important to overcome this aspect, to then be ready to develop real solutions which gives this consistency. So yeah, I finished my presentation. So that's our wish, that we start to make it doable for 2025. And I'm sure that the various suppliers will be ready to work on it. I think what is really great, and what you could see on this presentation, a lot of people were working together. I think it's a good example how to combine technologies of different suppliers, knowledge of different suppliers, to try to get a better product and to make something really good for this minting industry. Thank you.
Thank you. Christoph, don't stop having good ideas and talk to different people. And also from your side, Roman, very nice to include Rösler and Sparlek and to make sure we are heading off into the right direction. There are still many things to be done. Thank you very much. Please use the code, start raising your questions. You're already doing, we can see that on the screen. Thank you for participating. And this leads us straight into the next teaser. Alex, thank you very much for being here. I think I don't have to read this. You're well known for your machines and your fashion and your professional way of presenting. It looks like that you are merging now a decoating, coating, decoating also within your technology of laser. Your topic is streamlining production with laser PVD decoating, rapid digitization of plaster models. Stage is yours.
Thank you. Ladies and gentlemen, in today's time, I think it is increasingly important that not only do we enhance our sustainability, but also keep in mind that we need to be efficient and reduce cost. And because of that, this topic is called streamlining production. Before we jump into the presentation, a quick word about myself. My name is Alexander Arminidis. I'm the head of business unit Mint and Print, working for Axis now there more than 10 years actually, and I also have an engraving background, which I'm proud of. During this presentation, we will have a quick look at the company Axis. Who are we? Then we will talk about the efficient loop. Then you will see two new developments, the RAS, the Rapid Area Scan for digitizing your plaster model. And also then we will talk about a little bit more about PVD decoding with laser, which adds directly to the presentation you just saw from the Bavarian Statement and Intercode. And in the end, we have a quick summary. So who is Axis? We are currently the market leader for laser technology in the mint industry. We also have multiple patents. Just to name a few is the pulse forging technology to polish your surface with laser using femto technology, and for example, the randomization for frosting to imitate a sandblasted surface. Axis has 2 national locations and 3 international locations, which is Axis UK, US, and Axis in Austria. Last year we celebrated our 20 years anniversary, and even in that short time we were able to sell more than 2,000 machines worldwide. The headquarters of Axis is in the city of Kornwestheim, which is in the southwest near to Stuttgart, and our research and development as well as our factory is in Mittweida, which is approximately in between Leipzig and Chemnitz. With a wide network of various partners all around the globe, with our headquarters in Germany and with our international sites, we're able to sell and support the machines. And it's also worth mentioning that, for example, a lot of our partners and our international sites, they have all their own service team and their own service staff, which makes it very easy and convenient to dispatch people all around the world. So, the efficient loop, what do I mean with that? I think in the end, in order to be efficient, one of the things that we can do is to simplify things, to make it easier for your production and to apply multiple steps, even, for example, with one simple machine. So with what is already state-of-the-art that you have seen from Axis over the last few years, and in combination with what you will see today, I think we have found a very good loop and makes it very simple for your production. We start with laser digitization of plaster model, apply direct laser engraving and all the other applications. Now we can also do laser PVD decoding, and in the end everything is super easy because we work very close together with Kavco and have direct interfaces. So let's jump into the first new development, which is the RAS, Rapid Area Scan for digitizing your plaster model. With previous technologies, you only had a simple or single measurement, and you had slowly but steady had to scan the entire plaster model, which takes a very long time, as you see now in this example. So we scan the entire plaster model using a single information. It takes long. Resolution is good though. And with the new RAS, instead of having a single information that we scan slowly but steady, now we can scan a line. We use similar laser technology as well. We project a line that allows us to scan a whole segment that we can stitch together, which makes it much, much faster, as you see now in this example. So because this technology is now so much more faster, now it can make sense to integrate the scanner into your laser engraving machine, so you don't need 2 separate systems. And I'm happy to announce that if you have an Axis machine with micron precision, if it's a used one or you have it already, or if you buy a new one, you can upgrade it and you can choose the RAS now as option. For the RAS, there will be 2 versions. There will be the standard RAS and the RAS HD, some of the information you see now on the screen. What are the advantages? Obviously, the biggest advantage is the speed. It is so much faster. It's up to 30 times faster to previous technologies. We also made it so that it's very customizable. So you as the operator can choose the line width that you want to scan. So you can either choose to have a smaller line, more segments, higher quality, or you want to have a faster procedure, then you have a bigger line width, and then the scan is faster. The software will not show you what is the time for that scan, but it will also give you a live feedback of what is actually scanned. If you combine this technology with our camera systems, it's also very easy and very quick to set up your scanning process. We always work open source. That means that our scanned information is stored in a simple TXT file, and any modern CAM or CAD software can open and use that information. But we even made it more simple for you. We have a direct interface with Kafka, just a couple of clicks, and then you have the data open. You can start to work at your art, which is very important. Here you see a direct comparison. On the bottom, you see a real plaster model. On the top side, you see the scanned result. And all these fine details of the plaster are transferred from the plaster into the digital world. This example, it had a diameter of 180 millimeters, and it took only 15 minutes to scan. So the second topic, you heard about it already, is laser PVD decoding. And it was a fantastic project because it was driven by a mint. So the Bavarian State Mint had this beautiful idea, and then we invested a lot into perfectionizing the laser setup, the laser parameter, to get a perfect laser PVD decoding. We use a combination for the best results with picosecond and femtoseconds in combination. And not only can you remove the PVD coating with laser, you could also reapply a silver shiny looking effect with our pulse forging technology. Here we have a sample on the top left side. You see the sample, the material still has its original PVD coating. On the top right, we applied our decoating process. And on the bottom, you also see when we did the decoding and added our pulse forging process. And when you look at a zoomed out window, look at the details. There's still every detail is still there. It's sharp, clean, perfect. You don't remove anything. You don't alter anything. The design itself is as it was in its original state. It's also an interesting process, not only when the die is at the, or the coating is at the end of its life cycle. What happens, for example, if the die or the coating did not work in the beginning? In this example, someone touched the sample. Of course, we did that on purpose. But you see here there's a fingerprint, so the PVD did not stick to the surface. Usually what you're doing, you throw it away, make a new one, which is a waste. But with the decoating technology that we invented, you can recover that die, you can repair it, so to say, you remove the wrong PVD coating, and then you just do a new one. A lot of these samples that we did, and a lot of the processes that we developed, we did send to the university in Sofia, and they did a lot of studying on it, did a lot of measurements to it, and they confirmed to us that we can remove the PVD coating perfectly without leaving any residue whatsoever. There's also a scientific paper that exists on that. If you want to see that, please approach us. And as we also hear today, it's also possible to reapply a PVD coating after you removed it, which is basically very important. The best results by far we had with the femtosecond laser. Some of the PVD coatings can be removed with traditional nanotechnology, but because it creates temperature, it's very aggressive to the surface, the results are not the best. So use the femto for this one. So in the end, what this brings to you to the table is that with one single solution, with one machine, you can now integrate multiple processes. It makes it very easy. First, you start with laser digitization. It's very easy and very simple. There's no post-processing. We can transfer it to Kafka and back to the laser. We can do laser engraving. All the other applications like frosting, gradient frosting, rainbow, microtexting, your imagination defines what is possible. And then in the end of the life cycle of the die, it comes back to the same exact machine that you started with, and now you can also do laser PVD decoding. So it's one solution. It covers a lot of problems. And I'm almost at the end of my presentation. Now I want to show you a short video that shows you and explains to you how easy it is to do laser digitization with the new RAS. Enjoy. So for me personally, and also for the company, it is very important to stay very innovative. I think you figured it over the last couple of years. And it's not just to throw out innovations just to have them. I think they need to make sense for you and for us as an industry. And we want to show you a path of what is possible with modern laser technology that is tailor-made for this industry. And this path should definitely lead you to our booth D4. Thank you very much.
The sound on. Alex, thanks for your presentation, and just good to know that Access is at the same age as the World Money Fair Technical Forum. 20 years ago started, and we have the 20th Technical Forum. Your questions, of course, are welcome via Slido. You see here the barcode, just use it and ask the questions you have for Alex. Can we have, Julia, the next teaser, please?
Coins, an age-old tradition developed for centuries. But what if we told you that the future of coin design is at the brink of an opportune transformation? Enter artificial intelligence. Could this be the game changer in currency aesthetics? AI doesn't just crunch numbers. It decodes cultural narratives, historical symbols, and contemporary trends. Coins tell stories that adapt to our ever-changing world. Coins evolve with us. This impact goes beyond aesthetics. Robert Newman from Carve Co. will try to answer the questions. Can AI change the way coins are designed? Will it be a revolution or a fusion of tradition and innovation? To find out more, check out the Carve Co. presentation at the Technical Forum of the World Money Fair 2024 in Berlin.
Yeah, dear friends and colleagues, and to check this out, this is exactly the good reason for you to coming here. And we welcome Rob to present the leveraging of artificial intelligence in modern coin design and manufacture. Another Carve Co presentation, and I promise this would be another good one for you. So thanks for your patience, and Rob, the stage is yours.
Thank you very much. So good afternoon, everybody. My name is Robert Newman, and I am a co-founder and managing director at Carve Co. My journey into coin design from the software perspective began in 2007. And I worked out this has been about my 11th year contributing to the Technical Forum, so not quite the 20, but a few numbers of years that I've actually been here. It's always an honor, though, and a pleasure to be able to be here presenting with some wonderful presenters and hosts as we have every year. Today, I am really looking forward to taking a broader look at the impact of artificial intelligence on coin design and to see what this can actually bring to this wonderful craft. So AI has been a buzzword around design and language, ever evolving. And I promise that is the only pun that I'm going to make around this topic itself. With artificial intelligence, it brings excitement, but also a lot of controversy. It questions things like the morality, the ethics, and the ownership. Who does it all belong to if a computer has created it? But for today, I'm just going to ask one simple question. Can AI assist in design and the manufacture of coins? So firstly, every coin tells a story. It starts with a theme. The story itself could be to commemorate a historical event, to pay homage to a person, a portrait, or just to celebrate national pride itself. Once the theme, the story, has started, we then get to the next side, the design side, whether it comes from a sketch or whether the engraver gets a blank canvas. And the problem with a blank canvas is sometimes it causes brain block, same as writing a novel. you can sit there and you're kind of not sure where to begin. But when you do get to that point, then you've got the 3D model to start designing. And this is a very time-consuming piece. A very simple design could take 40 hours. A portrait with some detail in, around about 50 hours. But if we go more complicated, we can talk 150 to 2 hours easily, 200 hours, to a more complex design itself. But what does this actually tell us? Well, it tells us that traditional coin design isn't just a skill. It's a commitment to the time, the patience, and above all, the passion for artistry that engravers have. Every coin is not just a piece of metal. It's a canvas that tells a story. And really, it's a piece of history in our hands, and that's one thing not to forget. But it's not only time that's the challenge in coin design. To create the right piece, other things come into play, such as public acceptance, ethical considerations, regulatory compliance. A number of things all come into play when ensuring that a coin is created and it resonates well beyond its monetary use. So does that mean that we actually have an opportunity for AI in coin design? Does it have the potential to free up time, to give us space to actually think differently? Let's take a look at something that AI is really powerful at, and that's pattern recognition in the first image there. AI is great at sifting through and recognizing patterns, whether it's of a face or of a design itself. A great example of this would be Adobe with their background replacement. We've all seen that. You bring in an image and you can type in what you want and it will replace a background. Imagine this in coin design. For example, a boat, and you wanted the water differently behind it. Using AI, pattern recognition could, in theory, replace the background and give you variations of this quite quickly. Talking about variations, another strength of AI is iteration, ideation. For example, if I say, let's think, 5 coins, I'm going to design a series of 5 coins. Based upon historical data, designs, pattern recognition, it could design a series of 5 coins. A great example, let's say a series of South African coins, the big 5 coins. You could get it to design a series of 5 coins which look very similar and feel very similar. Quite a powerful tool, potentially. The next thing that AI is really strong at, as we all know, is research. It kind of acts like a super-powered librarian, sifting through millions of bits of data. Whether this is imagery or text itself, it's super powerful at research. But does this mean it's always correct? Here we throw a little example at AI, and we simply say to it, hey, why don't you create us a series of 5 coins? Simple. Let's make them all animals from England. Pattern recognition, research, great. These designs look lovely, but remember, I asked it to design 5 coins from England. First of all, one of them has 5 coins in, the others don't. Secondly, not sure about you, but I've never seen gorillas, lions, tigers kind of wandering around England. So does that mean its research is always correct or not? So what are the real possibilities? Is there an opportunity for AI? I do something slightly different here. I give it more context. I say to it, hey AI, design me a coin with a knight standing there with a sword in front of him, in front of a castle, brick-built castle specifically, but then I say to it, make it a bas-relief, make it high contrast. Let's see what it comes up with if I give it more detail. We all know the more detail you give AI, the better it is. Okay, it's come up with some quite nice designs. They're not reliefs, but they're designs. I'm going to take one of the bottom images, and I'm going to use another strength of AI, which is upscaling. We can see there's 2 different versions there, normal image upscaling and AI upscaling. Upscaling of AI gives you a lot more definition, detail within there. It manipulates some of the pixels to add that detail. And then I run it through a script. This script is very simple. There's a number of these about, and all this is going to do is turn it into a height map. That height map is something that we can take into Carveco itself. As many people know, Carveco is very strong at taking an image and turning it into a relief, and we do that. We do that with something that's created by AI text itself. And as you can see here, it's actually managed to create a relief. It's not bad, it's quite good actually. It's 1 millimeter in height. The more depth I add to it, 4 millimeter, actually comes up with something quite nice. There are issues and limitations with this. You can see there's significant banding. Anybody who's engraved before knows that banding's a bit of a problem to remove if you do get this. But again, in theory, this is quite an interesting process. But it's also quite a scary process to see what we've done. So then what I do next is I think, well, actually, how does an AI-generated image compare to an engraver? So I do a more realistic example. I take the exact same image, very high detail, something more realistic to what people are likely to work with is a portrait, an image of a person. So we do exactly the same thing, run exactly the same processes, but on the one hand, I have a mint engraver who took 150 hours to produce this at 0.3 millimeters. And as you'd expect from any mint engraver, just the separation, the detail, the lighting, the nose, the eyes, the detail that's gone into that chainmail is absolutely outstanding, showing the skill that they have. When I shove the exact same image through those processes in AI, it's an okay start. It took 8 minutes, so that's not bad. There's probably other processes that could be done, but in this case, it came out with something that may give an engraver a starting block, but actually realistically isn't usable. Why is this different to the previous image? The previous image is because I said create it as a grayscale, create it as a high contrast image, do this, and I got AI to do the work up front, which isn't really how you're going to work when you get an image from a celebrity, a person, a dignitary. So it's very different. But does it open possibilities? Maybe. So if we take a look at what some of the current limitations are, that banding is actually caused by the fact it's 8-bit. Converting this to 16-bit may remove some of that banding. The other thing is it's actually a different style of sculpting. The thing that we know about engravers and how engravers carve is it's not the same as what somebody carving out of marble or somebody carving out of wood. Now, what you saw previously, which that image that looked okay, is great for somebody hand carving, machine carving, doing things from wood. But actually, for engravers, where everything's got to be of a definition of 0.3 millimeters or slightly higher, it's a little bit more difficult. It's a total different style of sculpting. Iterations, though, is quite powerful for it. Being able to iterate your designs, change your designs, quite a powerful process itself. But the thing is, what I tell you and talk about now is not what it's going to be tomorrow or the next day. AI is developing so fast based upon the data that it gets that tomorrow what I've shown might be a total different story. Now, I also said that the presentation is about machining, and I can appreciate that I haven't fully gone into that because there's also another topic here and a lot of opportunities, whether it's machining or lasers, things like the optimization of toolpaths, energy efficiency, so thinking of things that are beneficial for mints itself, is working out the most pertinent time to run the machines, the speed to run the machines, benefiting from your energy efficiency, the quality control, based upon the fact that a lot of these machines now have cameras in, the ability to see the final design and change the final design is a possibility. And then things like data analysis and improving. The more data it works with AI, the better it seems to get. So just in summary, on AI itself, there's a lot of potential with it. It's a different style of sculpting at the moment. That's kind of one of the things that I noticed. The more designs I threw at it, the more I realized it is slightly different. Fact-checking, as you saw from that coin, is still a huge part. What AI gives you isn't necessarily always reality. It is super powerful for iteration of designs. Creating multiple designs is a superpower of it. There could be security concerns in the future, and I also feel like this is another topic in itself. I have done some testing on could somebody easily recreate the coins we have. I'm not going to go through that now, but again, a very, very interesting topic. I don't believe it's doable right now, but could it be in a few months? Possibly. And the other thing is, AI could be useful for error forecasting. The wonderful work that the Canadian Mint have done on their FEM, FEA, on stamping and things like that could be a possibility for AI within some of those sorts of things as well. So this brings me to the end of the presentation. It's just a brief show of what AI could do within the minting industry within the period of time that I have. I hope it was of interest. If you are interested in questioning me more, obviously we have a forum now, but afterwards I'm around for the next few days, so please feel free to ask me anything on AI and I'll see what I can do to answer. Thank you very much.
Rob, thank you very much. It looks like that artificial intelligence is always combined with a lot of opportunities and that little part of being scary, which you have also pointed out. Thank you. Please use still your phone to raise questions. There is some activity going on. We can already see that. You can also push your button to have the questions being pushed up to the higher level if you want to answers to one of those questions earlier. Can we have the next teaser, please, from the Hungarian Mint? Zoltan started in 2015 at the Hungarian Mint. Laser technology used for adapting raster graphics on circulation coins is your topic. Please start, Zoltan.
Good day, ladies and gentlemen. My presentation title is Laser Technology Used for Adapting Raster Graphics on a Circulation Coin. I will speak about 200 forint circulation coin and Sándor Petőfi's life, and I will mention some details about experiments, specifications, technical parameters, and at least I will speak about the new 200 forint commemorative circulation coin too. On the occasion of the 200th anniversary of the birth of Sándor Petőfi, a competition was announced by the Hungarian National Bank, Central Bank of Hungary, for the creation of a commemorative version of the currently circulating 200 forint. Sándor Petőfi is one of the most iconic personalities in Hungarian literature and culture, a poet who wrote the most translated poems into foreign languages. During his short life, he wrote nearly 1,000 poems, and he was also a revolutionary, a national hero, and the defining figure of the Hungarian Revolution and War of Independence. For the first time in the history of the 200 forint circulation coin, a commemorative version was released. The face value side is the same as the current circulation 200 forint, while the thematic side, instead of the usual chain bridge depiction, features a modern raster technique portrayal of Sándor Petőfi, which was inspired by the painting by Miklós Barabás. The thematic side of the coin was designed by an artist who is András Szilos. The technical parameters are the same as the current 200 forint circulation coin. Some mandatory formal elements of a legal tender, for example, the name of the issuing country, Magyarország, Hungary, the minting year 2023, were also added to this site, combined the official Petőfi anniversary logo. The outer part of the coin is made of a copper, nickel, and zinc alloy, while the inner part of the coin is made of a copper and nickel alloy. The outer diameter is the coin is 28.3 millimeters. The diameter at the ring and core junction is 17.9 millimeters. The rim thickness is 2 millimeters, and it has got an interrubbly age. The weight of the coin is 9 grams, and 1 million pieces of this coin were minted for this birthday anniversary. András Szilos prefers challenges and unconventional performances. This is where he got the idea of applying effects used in graphics and printing technology to coin production too. András graduated in 2009 from the Moholy Nagy University of Art and Design, majoring in metalwork design. The graphic proved to be a significant challenge in tooling process. The goal was to produce 1 million pieces of this coin with high yield and high quality. Minor adjustments had to be made to the artist's design because of larger empty surfaces appeared flowed in the 3D model. Finally, the pattern has got a uniform overall image. Before starting the tooling process, laser engraved samples were made. We came up with two options: the raster lines protruding from the base plane, or conversely sinking into the die. We used the later one. And we also agreed we follow the usual circulation tooling process. Before finding the right version, several variations had to be created to give the portrait a striking appearance, as varying the height of the relief elements wasn't sufficient enough. Initially, frosting was used on the raster lines, and it showed a better effect than the untouched version, but it wasn't good for us. The next step was to create a linear structure, which wasn't so good, and this variation was discarded. The first step was to create a diagonal structure, which also showed a better effect than the linear structure. However, it wasn't good for us. Finally, the last version was to create and combine the two best versions, the frosting and the diagonal structure. So this variation was implemented on the working punch. Let's see some technical parameters. A pulse frequency 500 kHz, laser power 8.3 watt, with continuous motion 800 millimeter per second, and the layer height. And now let's see dies. The first step was to create the master die on a CNC engraving milling machine. Technical parameters were as follows. Relief height is 0.2 millimeters, rim height 0.25 millimeters, and the inscription height is 0.08 millimeter. The first step was to create the working punch, mother punch. Here, the same parameters were as the master dice parameters. So relief height is 0.2 millimeter, rim height 0.25 millimeter, and inscription height is 0.08 millimeter. The first step was to create the working punch, where the measured technical parameters slightly changed after hobbing or pressing. So the relief height is 0.2 millimeter, rim height 0.24 millimeter, and inscription height 0.065 millimeter. The last step was to create the final die, where the measured parameters were as follows: relief height 0.18 millimeters, rim height 0.23 millimeters, and inscription height 0.05 millimeters. The working dies were given a hard chrome coating because of ensure shiny, stable effect. Manufacturing of the new 200 forint commemorative coin was required great attention and precision because of the pattern was extremely intricate and complex, making potential errors difficult to detect. And now let's see a short movie about the process. Thank you, and we are very proud of our colleagues because they were able to produce this 1 million pieces of this coin, which attracted the attention not only of the hard collectors, but also the ordinary citizens of our country. Thank you for your attention, and we will meet by our booth.
Thanks a lot for showing up and presenting us this interesting topic. And ladies and gentlemen, please do not hesitate in asking Sultan again, as well as the others. I've noticed you're very active. We have lots of questions already in the pipeline. We heard 5 presentations now, 2 of sustainability. We had tool-making laser trials, and we learned about coin design, and we very much looking forward to the Q&A session now. And I just want to start with the first one, and that was Goran who got the most hits on this question. That is for Shenyao, I guess. The question, is this technology already scaled up, or is it still laboratory scale? Shenyao.
We are on the way to scale up. As I mentioned, we already break through some milestones, and we're on the way to scale up.
Thank you, Shenyao. We can raise the next question. I'm sure there's one more coming for you, asking you specifically about what kind of chemistry you're using, so be prepared. Next question is for Roman. Thank you very much for your presentation. How can you guarantee that Chrome 6 will not be created during the laser treatment? Can you evaporate Chrome, react with oxygen?
So thank you for the question. Chrome 6 is a side product of a chemical process. So in our case, we are burning away the surface actually. And when you are thinking of tool steel, for example, in a lot of tool steels, you have chrome also as an element inside. And when you are engraving your tool steel by laser, you have the same process actually. So from our point of view, we don't see an issue. I think Alexander can also say something in regards of the exhaust or the fumes which are being produced when you are decoating or when you are engraving. But you need to understand I'm making coating equipments. I'm not a laser expert, so he will answer this better than me.
Yeah, maybe I can add something to that. Usually, especially in Germany, but I think all around the world, it is a required law that you use extraction units. So what you do is you have, when you evaporate the material with the laser, you have always filter systems that will refilter the air or the evaporated material. And these are HEPA filters, fine filters, pre-filters, so there's various stages, and I don't see any issues with that.
Thank you for this feedback. Happy to see the Deutsche Bundesbank here as well in the audience. There's a question for InnoCode. What influence has the carbide content for the tool steel on the polishing quality? Will it make sense to go down just on martensinic steels?
So also a very interesting question. Actually, we have tested a lot of different steels with different degrees of carbides, etc. Until today, what we could see, or at least where it made sense from an economical point of view, because this is also a question, how much you want to invest for your tool steel. We didn't found the perfect fit so far, but I'm quite sure that we will find a solution.
Thank you very much, Romain. The next one is also to Axis, and I needed actually to bring up my skills through Google to see what TiB2 is, and it's meant to be Titan dibiruret. And to Axis, can chrome nitride and T-biruret be removed too?
I'll be honest here, I'm not sure. I guess so. We tested many different recipes of PVD, and all of them worked flawless. Even recently, we did some decoating for other coatings that are not PVD, and that worked as well. So this doesn't matter what it is, as long as it's a metallic or ceramic coating so far. But this specifically, I'm not sure about it, to be honest.
Yeah, the next question is for, thanks Alex, but the next question is for yourself and Roman as well. Perhaps one of you knows the answer, or you both can reply and do it. How many times can the tool be recoated? Do you lose any surface attributes after a few of PVD removals?
So what we are trying to do is to not remove too much material from the die itself. So I'll give you an example. If you have a coating of 3 microns, so we are trying to remove 3 microns, 3.1 micron, because the problem is, as more often you are doing it, at one point you are harming the die material itself, and then you have a certain limitation.
Thanks, Romain. Next one actually comes from Kenny. I leave it the way, even though you pushed Patrick's one into place number 1. We'll have that afterwards. For the laser decoating, similar question actually than the previous one. How can the process machine make sure not damaging the die itself?
Yeah, that is something that we ask ourselves as well. And we did a lot of trials. We dialed in the perfect parameter. We also found a combination of various steps where we first have a parameter that reacts very well with the PVD coating, but not so well with the steel itself underneath, just to make sure that we don't damage it. I mean, there will be maybe in a nanometer, micrometer spectrum, there will be obviously some changes, but it's not really visible. And with a combination of different laser steps, we make sure that that we don't harm the die too much.
Thank you.
We're bringing Shenyang back in line with a question from Patrick. Thanking you for this scientific paper. And the question is, what the cons versus the chemical solutions for refining pure gold? Price, process, time, power, consumption? A few examples.
Well, as I mentioned earlier, right? So the mechanochemical process for the gold refinery is not high energy consumption. And the acoustic energy is actually in regular, generator, like transducer. So it's not like a high energy requirement. And of course, once you go to large production, the kilowatts will be in the range. Yeah. So in terms of the costing, for the overall costing, we're still in the process to combine the mechanochemical process and the electronics together. So from costing point of view, it's comparable to what we have been doing use the Miller correlation process and the electrolysis process. So the major breakthrough is the remove the chlorine gas in the Miller correlation process. We don't need a Miller correlation at all, so we don't need chlorine gas as a large quantity. Yeah. So related, health and safety consideration is also, things in the equation. So anything we need for the correlation process, that we will not need anymore. Thank you.
Thanks, Shenyang. Alexander, next one is for you. Thanks, Axis, for the interesting presentation. Question is, what if surface parts are not coated anymore?
To be again honest, I don't fully understand. Does it mean when we already remove the PVD coating and then there is the steel underneath it? I mean, then you will, depending on what settings you use, you will change it, but we will stop in before that already. So what we should do is only remove the PVD coating so there's no residue, but then stop kind of at that point.
Maybe I will just add something in this regards. The coating has also a limitation. Yeah? It always depends on what is the surface of the die itself. You cannot rework dies which have a hard die cracking, for example. It can be very complicated because then you would need potentially to re-engrave the die. And I know that there are also some ideas in this point to not only take the coating out, but also to analyze the surface quality and maybe to directly rework the die, especially when it was laser engraved, so that you can even think about reworking it and maybe to eliminate bigger damage.
Thanks, Roman. Yeah. The other question for Kaufco, and there's some concern. Do you think that artificial intelligence will take away the need for engravers?
All right, so I feel I've got to be really careful when I answer this question with the fear of possibly getting cancelled from this. No, do you know, the thing that I always find interesting about any new technology, and this will be the same when we came in as ArtCam and we came in as Carveco, is the fact that it's another tool to your toolbox. The same as when any new tool comes into anything, it's just an additional tool, an additional skill that people use. We came in as digital software, but there's still a lot of hand engravers out there. There's still people doing stuff, still people creating stuff in plaster, digitizing as we saw. So again, it's just another skill to streamline a process or to improve something. So I don't ever really see it going away. I just see it as an improvement, really, or an additional tool.
Thanks, Robert. Next one is also for you. Artificial intelligence. Please, can you elaborate a bit more about the security concerns that you mentioned using artificial intelligence on design aspects?
Yeah, so I suppose the scary thing could be is if a circulation coin could be easily copied. There's obviously ways in which people do it at the moment, or have done it for years, which is, digitizing, scanning, but obviously there's problems when it comes to that, and it's noticeable. But could the potential of AI being able to create something quite high quality and detailed replicate from a text prompt what we produce and what is out there? At the moment, the tests I've done on coins and ones that are out on the market, looking into them, it's not there yet. Could it be? I think the possibility could be there for certain things. So I believe that this is something that, as an industry, we need to seriously think about in the future going forwards, because we don't really want people to be able to sit there and type and create coins that are already out there. So I see this as quite a big issue in the future. Right now it's not, but as I say, AI is moving so fast that it could be. I don't want to scaremonger at all in any way, because I don't believe it is there yet, but there's a possibility. So something we need to look at as an industry.
Thanks. We're bringing Zoltan now in line with the question from Michael. Zoltan, many thanks for presenting this nice coin. And the question is, how long was the project time for this coin, from the first idea, design, to the first minted coin?
Thank you. So, if I'm not mistaken, this project started in September 2022, and it finished in February 2023.
Thank you, Zoltan. Next one comes from Jens. Thank you very much, Jens, for raising this question to Access. Alexander, one machine can do quite a lot now. How about maintenance and service?
Laser systems in general are very easy to maintain. Recommended once a year, and no matter how many components you add, the same cycle of maintenance applies. I mean, usually we pre-install a lot of remote tools that helps us and verify any issues with the system. We have free hotlines, a big team that helps and can even check the machine via the internet. So there's no big difference to it and no big issue.
Thanks. We still have a number of questions on, and we should continue, because I think the coffee is already waiting for us outside. The other question for CARVCO: is it possible for an artist to teach artificial intelligence his or her own style and provide instructions for generating unique designs using the learned style?
It's an interesting one, because it's something I looked in, because AI is well known for being able to, in language, write things in a particular way, the way of your favorite author, or to design things in the way of a particular artist. If anybody's ever tried any of those and to create an image in the way of a particular artist, it's not bad. It's not far off what it could be, or you want it to be. As for the tests that I've done in doing the coin design type stuff, at the moment not, but because it can do pattern recognition, I do believe that the potential will be that it could sift through a library of coins that your mint has done in your style, and even possibly even a particular artist, and also reproduce designs in that similar style. So again, I believe it's a possibility that could come forward in the future.
Thank you very much, Rob, for short and sweet answers. We need to keep doing this, looking into the break. Next one is to Zoltan. You have mentioned high yield. What was the number of produced working dice?
Yes, 10 working dice were produced, because of the pattern was extremely intricate and complex and thin, and we had got a short deadline. So we decided that we had to minted these coins with 2 Graibener machines at the same time. Maybe if would have more time to solve this project, the yield was better.
Thank you, Sultan. I guess the next question is for Shen Yao from Rutger. That question is, how would you convert liquid gold to solid gold with fine composition?
As I mentioned during the presentation, the incoming gold is in solid condition, right? So once mixed with the special oxidants we have identified, so the 2 components together within the acoustic energy and bombardment, so localized heating, but not the bulk heating. But localized heating could be quite high, and the thermodynamic and the kinetical effects combined together between the molecules is the main driving forces for the dissolution of the gold, transfer the solid gold into a liquid. That's kind of main mechanism. From science point of view, I have read a lot of scientific papers during the process. Even the scientists have now figured out what exactly happening between the molecules in this process. And this actually also reminds when I did my PhD 30 years ago, I was doing the mechanical mixing between pure aluminum and M2 high steel. One is very, very hard material, one is very, very soft material. But because they have a mechanical mixing together doing that high-speed sliding, they actually create that transformation and damage the M2 steel. So this has been used in aerospace. So this is the kind of a pure mechanical mixing, but in this process we're working on is a mechanical chemical process. That the special salt I mentioned is also played very, very critical role in this mechanical chemical process. So it's not the traditional dissolution. As I mentioned, the Acquaregio process, that's pure chemical, but of course using very toxic chemical. But this one with the mild salt, but the chemical reaction is the key things for the transformation from solid to liquid. There's a lot of interesting, as I mentioned, even in scientific community.
Thank you, Shen Yao. That wasn't short and sweet, but it's okay. Next one goes to Rob. Is there any investigation started on using artificial intelligence to identify potential coining challenges due to the coin design, which is mainly referring to metal moving?
So I do know what this comment and question is about, and obviously that's referring to a holy grail of a problem which the Canadian Mint seem to be leading the way on, which is the FEM, FEA metal material moving. And this has obviously been looked in for a long period of time. Something I believed a while ago was I said a heuristic view may be the solution to assisting with FEM and FEA on this subject. And I still believe that this, combined with the FEA, FEM, and the AI integrated, could be a very, very promising solution. The problem I see with it is that AI requires data. And it's great one mint producing their coins in-house, but obviously this could take a period of years. The biggest problem is it requires the data from lots of different sources to do this successfully. So, and obviously that's something that isn't exactly feasible within the industry. For one mint to do it, I think it would take a number of years. But if you started doing it, it could potentially add 1 or 2% improvement, and over a period of years, it could get better as it does it. It's not there now, but again, there's a lot of potential with this in that holy grail of a challenge to save on time. I suspect the Canadians might start looking at it.
One more for Alex for Access. Only femtolaser only applied to decoding PVD?
No. As I said in the presentation, so the initial trials were made by the Bavarian Statement, and they used the nano laser to it. Obviously, then, when we went into investigating and developing it, we found out that obviously the ultra short pulse technology is much, much better. But in fact, some of the PVD coatings can be even reduced with nano laser technology.
Thank you very much, Alex. To Zoltan, do you have any problems by producing the coins because of the raster graphics, such as stay behind of the blank materials?
We had got a problem with two colored parts because this was very hard to display the portrait on this bimetal version. So we had to make a lot of experiments, and that is the reason why we use the combination of the two best versions.
Thanks, Zoltan.
Thank you. We have some more questions in the line, but we have 2 more days of exhibition and the networking time today as well. So if your question has not been highlighted right now, there are still opportunities to talk to the presenters, and please give the presenters now a big hand for not only presenting, but also answering all the questions. And a great applause for you. That was a very active session, and thanks for all the questions you have given to us. And thanks to Argosy for sponsoring of coffee and drinks and some goodies outside. This is waiting for you. We're a little bit out of time, so we will call you back in about 20 minutes. Listen to the gong and don't miss the next session, which we're having with another 5 interesting presentations. So coffee is yours, and enjoy the networking. Thank you.
Let's start with the teaser from Proditech, please. Eric, you're personally and also your company, I think, is very well known in the market. Your today's topic is sorting results prediction, a key to a greater quality and production. If you don't mind, start your presentation now.
Okay. Thank you, Thomas. Thank you, Mint Industry colleagues. Thank you for coming over. Thank you to our moderators for their great organization year after year. So, imagine how simple things would be if we had a tool that could predict the future in an industrial way. This is the mysterious yet promising purpose we mean to achieve with our SRP feature. Let's see why and how we had this idea. So really, it's all about context. You all know the context, you live in it, so you know that sustainability is an issue, you know that costs are going through the roofs, quality is always increasing. So we need unprecedented levels of efficiency. So at Proditech, when we need efficiency, what we do is we apply the overall equipment effectiveness formula. It's just a number, really, but it's quite carefully designed. So how it works. First, you ignore the time where you are not planning to produce. Then you look the time losses due to equipment breakdowns. Then loss of time because of speed loss, and most importantly, loss of time producing items that you are going to scrap or quality. So, in summary, this tool helps to focus on 6 points that are responsible for most of the industrial losses, also known as the 6 big losses. So let's apply this very simple tool to our best-selling machine, the VISIA CM for coins and coin blank inspection. So when we analyzed our support log, we found out that one assembly only was responsible for half of the breakdowns, this assembly. And therefore, we had it replaced by that assembly, that new assembly. It's a bit expensive, but all in all, it's hardly ever breaking down, so it's a great improvement. Then we saw that the setup of the mechanics on our system takes like roughly 5 minutes. But the software setting takes anywhere between 5 minutes and 2 hours. So any tiny improvement there means a huge impact on the effectiveness of the system. We'll come back to this point a bit later. Next, we search for what causes small interruptions of production. And we saw that most of them were caused by the users micro-adjusting or fine-tuning the detection algorithms. So we designed a specific feature that allows to fine-tune every single camera very easily and every single algorithm while the machine is running. So with that, we eliminated this small loss of time. Then we observed that reduced speed is often caused by a lack of will to push the machines. So what? Well, a machine that you push is a well-maintained machine, while a machine that you don't push end up like with patches like that. So we really want to avoid that. So what we introduced on our software is a judgmental speed gauge that tells you which speed you should be running, just simple with a color code. And we are thinking in in being a bit more intrusive in the future. Finally, and most importantly, the quality of the sorting. Sorting is not easy. So it's either you do it right or use something that looks like sorting but is not really sorting. So why am I saying that? It's simple. It's because sorting, people have in mind a very binary image of sorting, something like that. But in reality, sorting is a bit different. It looks a bit more like that. Every decision is difficult and complex with many criteria. So to make these decisions, you need a complex tool. So here we are. We have a difficult process. We need a complex tool to do it. So it's looking tough. And wet, because it's getting even worse. We have a setup procedure that we are going to describe now. As you remember, the setup of the software is 95% of the setup. So let's see how it's done. So as you will see now, it's quite a lot of coming up and down, manipulating coins, a lot of coin handling, and a little bit of setup per se. So we said, okay, we can't improve, we can't make sorting easier, but we surely can improve the experience of our users when they are adjusting the machine. So here is our proposition to make things easier. Our software has the capacity to store a large quantity of images for later simulation of the production. So you can replay any strategy of setting several times up until you find the strategy of setting that gives you the best results, and all this without coin handling. So let's see now how it's working on the machine. So we select one defect in particular. Here it's the rim defects. So we have a library of real defects of coin blancs on the rims. So first we play with the settings, and instantly we see the effect of the setting on one coin. And then on the push of a button, you immediately see the effects of your setting on a population of coins. So this is where it's getting interesting, because immediately you have the big picture. So you can try different strategies, and immediately you know what it's going to do when you push the start button on your machine. Immediately you know how many coins, good coins, will be rejected, if there are, and how many bad coins will be actually removed. And all this with any further coin handling. You just handle the coins one time, you put them through the machine, and then your library is done. So it's a much more rewarding process for the user, and you achieve a much better result. So the process is very similar on the coins. Actually, it's even easier, because on a coin, thanks to the design, we can do a pixel-to-pixel comparison. And yeah, as a consequence, even on images like that with noise, we can easily just detect the defect that we are searching, and we are not annoyed by the bad background. So with this feature, we see that we reduce the coin handling to 20% of the total setup time, which is quite nice. So it gives more time to the users. Okay. Now, well, here let's see how it's working also when we couple the SRP with artificial intelligence. So it works exactly the same way, except instead of playing with the parameters of settings, you just leave the artificial intelligence to do it for you. But yeah, all in all, it's working the same way. Just when the deep learning is done, then you just validate that you are accepting your good coins and that you are rejecting the bad ones. So yeah, for people who want to play live with these two features, the artificial intelligence and the SRP, we invite you to come over and visit us at our booth before we are together with our friends from Rossler. And yeah, we'll be glad to help you with that. So yeah, all in all, what we see here is just by applying a very simple tool of overall equipment efficiency, we managed to have efficient questions, and we managed to very simply improve the reliability, the effectivity, and the quality of our system. And the same, if you are interested in this methodology, you can come over and visit us. It will be with great pleasure. We will help you with that. So thanks a lot for your attention, and see you around. Thank you. Bye-bye.
Yeah, ladies and gentlemen, ready to ask the questions. Here's the QR code for Eric later in the Q&A session before the next break. Thanks for your presentation, Eric. Great one. And can we have the next teaser, please? Yeah, ladies and gentlemen, if this teaser was not clear enough, here are the presenters, Christine and Juan. Christine, it's always good to have a customer on site if you want to talk about new technologies or new innovations. And as you know, every coin has three sides, the obverse, the reverse, and of course the edge. And you're talking about how we inspect and how you inspect the edge and how important that is in the inspection process. So the floor is yours. Big applause for the two presenters, please.
Good afternoon, everyone. Christine from Spalet and I, Juan from Cecosa. We would like to present a new inspection technology for the edge in the coin and the coin blank. In Cecosa, we wanted to increase our quality level because we didn't have the possibility to analyze the edge lettering. In this way, we found a solution from Spalet that was able to meet our requirements. We have combined, on the one hand, 25 years of experience in manufacturing coin blanks, bronze plating, copper plating, nickel plating, to copper alloys, stainless steel, aluminum, and on the other hand, the knowledge of the Spalet that bring more than 25 years in the international meat industry. The result was that Spalet developed a new system based in a hypercentric lens and mirror system that in greater detail, as Christine will explain.
We could convince Juan and his colleagues with our previous system. The coin for coin blanks can be rotated over a turning wheel to be inspected from both sides. Our 3D system checks the geometry of the coin or coin blanks, for example, the diameter, the thickness, the ovality, or the bending. Then the 2D system with its color camera inspects the surface for damage or contamination. Only the edge was the missing thing to inspect. On the demand of Cecosa, we are now integrating it to our system. Here you can see the optical setup of our edge inspection. The heart of it is a catadioptric lens, a combination of lenses and mirrors that can look to the side of an object in a hypercentric way. We chose a camera with a good compromise between resolution and light capturing because light is the limiting factor of this system. Therefore, we installed a high-power LED ring light which looks with a shallow angle to the edge of the object. With this setup, we are able to have camera exposure times from 100 microseconds. And this is very important for us because we want to integrate the edge inspection to our existing machine, the SID 200R, which can inspect 2,000 coins or coin blanks per minute. Here on the left side, you can see an image of a €2 coin with the edge inspection. And on the right side, there's a sketch of a camera and a lens and an object underneath it. The image of the edge inspection is divided into two main parts. The part in the middle results from a, let me say, normal way to look to the object in a pericentric way. And the part around it results from the look to the side of the object in a hypercentric way. And only the small part which comes from the reflections of the edge build our area of interest. In this area, we can see symbols as high reflections, which are quite easy to detect from our software.
In this next slide, I would like to explain how we define the criteria to stabilize or to teach the machine. In these images, we can see the coin blank that we are using as a reference. It will be our green light. Below, you can see different coin blanks with different effects that we have produced in order to simulate a ROM production. All the defective blanks were detected by the edge inspection. And now, Christine will be explaining the Spallet software for the detection.
We work with a reference image. This is the image of a good coin or coin blank, Juan's green light. In the edge area of this reference image, we define areas of interest, our zones, which are typically over the symbols. When the object image is taken, it is aligned towards the reference image so that the symbols fit into their corresponding zones of the reference image. In every zone, we calculate statistical criteria, and if one result differs too much from the result of the reference image, the affected zone is marked as fail.
Now, we would like to explain how Spallet defines the algorithms that they are using to detect the defective coin blanks. The coin defective blanks can be used several algorithms for detecting. The algorithm that the Spallet developed is based in simplicity and efficiency. False symbols or symbols that were lettering on the top each other were detected by the expression can evaluate it for several algorithms at the same time. Very simple algorithms can be evaluated if a symbol is present or not, as long as the coin blank is in the exact position.
And this poses our challenge because the image of the edge inspection differs a lot depending on the position underneath the optic. Here on the left side, you can see an image of a €2 coin very well centered underneath the optic. And on the right side, there's an image of the same coin very much shifted underneath the optic. And you can see that the shape of the coin is not more circular, and also the width of the edge area differs depending on the position underneath the optic. Positioning is depending on two main factors: image triggering in running direction and mechanical guidance perpendicular to this direction. Of course, we can detect major positioning errors, and the affected coin or coin blank has to do another round in the machine, but we still have to deal with that problem because it cannot be completely avoided in practice. Therefore, we improved our image triggering by using our 3D system as image trigger for the edge inspection. Another problem is that with the problems with the distortion of the image increases with the depositioning. Therefore, we also had to find a way how we can eliminate the distortion in the image. Now I want to tell you why our 3D system is so suitable as image trigger. Our 3D system is a triangulation system that consists of a camera and a laser arranged in an angle to each other. Due to the triangulation angle, the shape of the laser line projected onto the imager of the camera corresponds with the height of the object underneath the laser. When the object passes the laser line, the camera is taking pictures permanently. And by extracting the laser lines out of the images, we get many sections through the object, and by merging these sections together, we have the 3D model of the object. And we define the center of gravity of the projected object to the bed as our object position. And when the encoder says that exactly this position is underneath the optic of the edge inspection, we trigger the camera of the edge inspection. I also told you that problems with distortion of the image increases with depositioning errors. Here you can see an image of a checkered sheet of paper. The lines in the area where the important edge information is are very banded. This leads to problem by matching the symbols into their corresponding zones of the reference image. If the object is centered very well, the distortion at the positions of the symbols is very equally distributed and the problem is balanced out. But if the object is shifted, the distortion at the positions where the symbols are differ a lot, and so it can happen that one symbol does not fit into its zone anymore. This leads to failures by calculating the statistical criteria in that zone. Eliminating distortion is a common way during camera calibration, but on the market we could not find a suitable target for our specific kind of image of the edge inspection. Therefore, we had to design our own target. Different from common use targets, it works with polar coordinates. Black dots are arranged in the area where the important edge information is. We place this target in many orientations and distances to the optic. And by detecting the coordinates of the black dots and by knowing their real position on the target, we get an overestimated equation system which gives us a mathematical connection between a distort point and an undistort point. And by using this mathematical connection, the banded lines in the checkered sheet of paper become straightened. All in all, we can use our edge inspection to look for missing symbols or symbols at their wrong position. And with the help of the reference image, we are also able to evaluate the quality of the symbols to a certain degree. By using our 3D system as image trigger, we could make our system more robust against positioning errors. And by eliminating the distortion in the image, we are now able to evaluate zones that are at the same size as a symbol on the edge of a €2 coin. I want to take this opportunity to thank SECOSA for the very good cooperation and to make this project happen. And I also want to thank Jörg for his tireless support and his excellent technical expertise.
Thank you for your attention, and we hope that you enjoy with the presentation. Feel free to ask any question. Thank you.
We are looking.
Juan, thank you very much for trusting us. Christine and Jörg, thank you very much for putting in so much effort to get all this done. I know you have lost half of the audience when it came to the deep technical elements, but I think this needs to be presented to assure that also inspection has not come to the end of their days. Thank you very much. Please formulate your questions, put them into the system so that we can have the Q&A with nice questions, which will then get answers. Can we have the next teaser, please?
Overin is an invisible digital code for physical products. You can read this invisible code with your smartphone and be linked to any landing page. You won't see any difference between products with and without the Overin code. Your product with Overin code can be produced by transfer printing, by CNC milling, or by laser engraving.
Thorsten, thank you very much for being here. You have been invisible, as this is part of the slogan, but you're now here because you have been guided all those tests with Overin as the managing director of Roy Coins and Medaillenmanufaktur, so you can confirm that what you're going to present is real. Thank you very much for being here, and please start your presentation.
Thanks. First of all, I want to thank you very much, Thomas and Dieter, for organizing this 20th Technical Forum here on the World Money Fair. And I'm very thankful that we have the opportunity to present Overin as a new product here on the World Money Fair. On behalf of the company Cybe Concept, it's the development partner for Overin, and welcome you, the audience, for attending our presentation. My name is Thorsten Dallager. I'm the managing director of Roy Company, and we made a feasibility study and analyzed how Overin could be implemented in the coin industry and the common process of production. First of all, I want to show you what Overin stands for. As you see on the slides, Overin, the name is for authentication, verification, and it stands for information. So that means digital dynamic information could be connected to a real product, and the user, so the customer or the buyer of coins, bars or metals, could be verify the purity or the origin of a product. I want to show you some short facts about Overin. As I mentioned before, Overin is not a real product, it's more a digital process which could be implemented in a real product, for example, like coins, ingots, or metals. This is done by linking an optical code which is integrated into a design for a coin, for example, and this code is almost invisible for human eyes. So you cannot see this code in the design you've generated, for example. And this allows that the user or the collectors can scan this code using a mobile device, like in iOS or Android mobile device, with a free available app in the App Store. And this is the way how the product becomes a smart product. That means it is connected to the Internet of Things. And therefore, there are many opportunities to provide information to the customer. And also the safety is a big issue, I think, for different kind of industries. And so this code, which is integrated in the product, is not a code which contains any information. So it contains a sequence of number which is encrypted on a safety server. And then after encryption, the user is provided to a landing page which could be provided by you as owner of the code. What we want to present you today is the opportunities of the production processes in the coin industry. So we made different tests for the feasibility in different kind of production processes, and we checked the results, if it's scannable by a mobile device, and if the results are readable by the users. So just to explain how it looks like, so we see here two different kind of coins we have produced for the company Saib, and one coin is with Ouroring code and the other coin is almost without an Ouroring code. So it's at the moment it's almost invisible to the human eyes if there's a code or not. So to understand the process, if you have a grayscale data, the company Saib will integrate into this grayscale data this optical code, and it's integrated in this way that is not visible with the human eyes. The second option is that you print this code by a printing process, and therefore you have to provide an image data which then could be used for the printing process. And as you see here, the appearance of the coins are almost the same. What we've tested in this feasibility study are three different kind of production processes. So we made the tooling for the company Saib by laser engraving, the second one by CNC milling, and the third production process was the transfer printing with digital printers. And all these three methods was tested for different kind of products, and the result was that every coin was readable by the scanning app, and all the information could be provided by the security server. Just let me show the test results of the different kind of productions. First of all, you see here the coin, you see on the slides before, and we made the tools by laser engraving. It was a tool with a diameter of 33 millimeters, and therefore we used our fiber laser from the company Axis, Piranha 2. And what's very important to mention, the aim of this analysis of feasibility was that we have not to change the requirements or process parameters. So in this case, we had a lever beam width smaller than 30 micrometers and a relief height about 0.07 millimeters, and we we removed layers, 200 layers, with a dimension of 0.3 micrometers. So the whole process takes the same time also with and without Wolverine. So we have not to change any parameters in the production process, and also we need no special requirements by programming it or set up the machine. What's also very important for some of you is it also visible with PVD coating? So we don't use this PVD coating at the company Roy, and therefore we ask the MIND Baden-Württemberg in Stuttgart if we make some tests with the PVD coating. And so we coated one tool with titanium diboride, 1 micrometer. And thank you very much to the MIND in Stuttgart that we had this opportunity. And therefore they used the Blathead SM Plus, and it was also very convinced that it works, and the tests are okay. So we could also read the coins out with this coating. The second test, so we used the common known CNC milling process. Therefore, we produced a tool with a relief height of 0.2 millimeters, also on a standard machine from the company Lang, an Impala 400. And we have also no changes regarding the tools we use. So we have, in this case, a sphere cutter with a radius between 0 to 5 millimeters up to 0.5 millimeters. And also our used grave cutters, we have no special requirements in this tooling. The second test takes place regarding the printing technology, so that Wolverine was printed on different kind of coins. And therefore we made also some tests with different kind of bed printers. And here you can see that we also use different kind of inks, like an UV ink technology or a terminal coloring ink. And during the test, we also tested the minimum resolution, which was 720 to 600 dots per inch, and it was always readable by scanning the code from the coin. So regarding the printing process, there is one special thing to mention. So if you use a tool for embossing a coin with the Wolverine code, so the code is fixed. So every coin has the same code, which is made from this one tool. So the printing technology allows you that you can connect each coin with an individual code. So this is possible by the printing management of different kinds of printer. So if you have, for example, like a CSV table where you could put in the number of coins you want to print, so each coin gets an additional optical code element which allows you to connect new digital information to each coin. This allows the user that you can connect each coin, for example, with a serial number. So if you think about different kinds of collectors issues, maybe this is very interesting. Yeah. After producing the coins, the most important thing about Wolverine is scanning the code and seeing the results of the connected landing page about the security server. So as I mentioned before, Wolverine can be scanned by the Wolverine app, which is free available for each user, or another optical scanning app. And it works with all iOS and Android systems. We also tested different kinds of scanning situations. For example, a scanning through a capsule. This is also no problem. And in the collectors industry, maybe there are some surface adaptations like oxidations of coins. And we also tested this in the feasibility study. And this was also possible to scan. What is also important is that the information you can connect to this real product is very dynamic. So the administration of the information can be done by each provider. So you can always switch information on the landing page by adaptation of the landing page. And afterwards, the users, after scanning, will be provide to the security server, and the security server encrypts the code which is integrated in this optical application, and then will be provided to your website. Just to summarize what Overeem means for you as a provider. So as I mentioned, Overeem is very flexible. So you can use it in different kind of production processes like minting or printing. And it's also a hybrid innovation. That means that it's an opportunity to connect physical product to the digital world, like the Internet of Things. And yeah, so another opportunity is that you can provide information about authenticity, for example, the purity of a precious metal or limited editions. And what's always very important is the privacy of data. So because the code doesn't contain any information about provider or user, it's 100% privacy. That is very important, I think, in these days. The point 5 means counterfeits protection. So you cannot copy what you cannot see. So if you imagine somebody does not know where the code is integrated, it is very difficult to copy it. Yeah? And that makes a product more safe than with a visible QR code, for example. And applicate this code on a product, it doesn't change any purity of the used material. So if you think about a precious metal, there's no influence on the precious metal. So last slide, some advantages the SIPE concept sees in this concept is that Overeem could be a digital certificate which is permanently fixed or linked to a product, and it's not visible with human eyes, so there is no restriction regarding design or anything else for you. And the product is afterwards linked to dynamic information. That means that you are able to change all this information at any time. So maybe, if you know about copying your products, you can send a warning on the landing page, and everybody who scans the product sees, okay, there will be coming up a problem. Yeah. So the test shown that the common known minting processes are available for Overeem, so you don't need any additional tools, requirements, or costs. That means if the code is integrated in the design, it is visible for everybody who uses this code in his product. Yeah, last but not least, some ideas what could be used or Overeem could be used for. So it could be used for our authenticity tests, for marketing concepts in the collectors industry, or provide information about product life cycle, or connecting a real product to digital values. So many thanks for your attention, I hope you've seen what is possible with Aurene, and maybe there are any interest to check out how it's be implemented in your product. Thank you very much.
Thorsten, thank you for presenting and this topic on the security, and please have a seat. And friends and colleagues, please don't forget to raise your question with the barcode on the Slido tool for Thorsten in the later Q&A discussion. Can we have the next teaser, please? I guess you are all very excited because for the first time, Comscore, the Korean minting, security printing, and ID card operation presenting here at the Technical Forum. Welcome, Jae Kim, for presenting, of course, and the topic you have when we talk about lightweight, high relief of thin coins in a large area. This is a topic everybody should be interested here, and we are interested to learn how the Korean Mint worked on this topic. So please, big hand for the presenter.
Thank you so much. Ladies and gentlemen, I am Jae Kim, Mint Technology Researcher of Comscore, the Mint of South Korea. At first, I'm very glad to have opportunity to make a presentation of Comscore's technology at the World Money Fair Technology Forum. The topic of my presentation is fabrication technology of lightweight, high relief, thin coin with large area. Oh, sorry. Before introducing the technology, let me briefly introduce our company, Comscore. Comscore is the comprehensive mint of South Korea, directly manufacturing banknotes and coins. So, Comscore has developed security technology to high level for 72 years. On the basis of accumulated anti-counterfeiting technology came from this, various national identification documents such as passports and ID cards are produced by Comscore. Currently, Comscore is expanding into the ICT field with mobile identification card, brand protection, and gift certificates. Especially in terms of minting technology, Comscore maintains a high level of technological development across all manufacturing processes from A to Z. And these are the coin products of Comscore. As you can see from the left side, Comscore have released various colorized commemorative coins and medals, as well as selectively plated medals in different colors. Comscore also developed high relief and three-dimensional medals in various shapes. And recently, Comscore started to release the note time medals in various forms and sizes inspired by banknotes. Next, I will talk about the topic of my presentation. The product introducing today from Comsco is the Dinter coin. Here, Dinter is compound word of sintering process and a word thin, which means hollow leaf thin coin fabricated by sintered blank. The most significant features of this pure silver coin is hollow leaf of 2.6 millimeters with minimal weight of 35 grams and very thin background plate of 1.2 millimeters and very large area with a diameter of 60 millimeters. Owing to the hollow leaf, over twice relative to the thickness of background plate, Dinter coin provides stereographic feeling and much more freedom in aesthetic expression. These are the magnified images of Dinter coin. Comsco possesses CNC equipment and laser engraving machine for minting die manufacturing. Dinter coin was fabricated by these equipment. And additionally, a Korean emulsion was incorporated on the reverse side of the coin by applying line art technique commonly seen on banknotes. This is the development process of the Dinter coin manufacturing technology. Although the whole process is not different from general cases, the key to completing technological development was the blank fabrication. As mentioned before, due to Dinter coin's severe specification compared to the regular coins, optimizing the blank specification was very crucial. So we conducted coining simulation to perform numerical optimization, and we optimized the sintering process conditions to satisfy the derived blank specification. Afterward, practically fabricated blank samples were examined to determine its practicality by coining test. The feedback from the result was continuously provided throughout the entire development process. Let me explain the coining simulation of the blank in more detail. As mentioned before, the Dinter coin was fabricated using sintered blank. Due to the characteristics of the sintering process, the sintered blank is inevitably porous. Therefore, to obtain reasonable coining simulation results, proper material properties had to be assigned to the simulation program, since the deformation behavior must be different from bulk state. So we conducted compression tests on a few blank samples and obtained stress strain curves. From this, specific material properties of Dinter coin blank were applied to the simulation program. The actual simulation was performed using the finite element analysis program, FORGE, focusing on optimizing the blank specification. We conducted shape optimization first and explored detailed specification for the optimized shape of blank. Simulation results were analyzed based on various criteria, such as the coining completion load, the degree of relief and pattern formation, and strain rate. During the numerical evaluation of various blank shapes, certain requirements were identified. As you can see in the left side of this page, based on these requirements, the numerically optimized blank shape was derived. The detailed specifications of the optimized shape of blank were refined much more through repetitive simulations, as you can see on the right side. Related to this, additional feedback and modification process were conducted by actual coining test of the corresponding blank sample. As a result, several solutions were implemented to address practical issues such as deformation traces on the reverse side, as you can see in the blue box at the center of this page. However, separated from numerical optimization of blank specification, practical manufacturing of optimized blank was a different challenge. Particularly, the large diameter of the blank and the extremely thin background plate were significant obstacles, leading to very severe density gradients within the green compact. To overcome this and satisfy the requirements for the blank shown in this page, appropriate manufacturing process conditions were continuously explored, and afterward, sufficient trial and error, we successfully secured the fabrication technology for sintered blanks with minimized distortion and satisfied detailed specification and over 85% density achievement compared to the silver. Up to now, the technological development of Tintercoin is explained. Although this is not the perfect technology without any single flaw, but it is a product that we developed with great passion and challenge. Through this presentation, we hope to garner more interest in our COMSCO. This is the end of the presentation. Thank you for your attention.
Greg, thank you very much for taking the long way from Korea to this place to let us know about less material but still high relief and shaking the interest of the audience and the buyers. Thank you very much. Take place. Raising questions I don't need to mention anymore. Let's save time and we'll go to the next teaser, please. Shown already, SEMSA, Raul Montero belongs to SEMSA, SEMSA to Heimerle and Meule, and you are going to show us 4.0 fully automated production for coins. Thank you very much.
Thank you. Good afternoon to you all. Good to see you here. Thanks, Dieter and Thomas, for keeping this going, okay? The technical forum. So my presentation is about the evolution in terms of automation of SEMSA during the last years. I will start presenting the milestones during the last years. Second, I will present the fully automated first silver bullion line, focus on 1 ounce silver production. Next, I will present the second silver bullion line, more flexible, and I will present afterwards the gold bullion line, fully automated also, coil-to-coil production. Also the initiatives in automation that we have carried out in the gold commemorative lines. And last, I will introduce you our evolution to 5.0 and the works in sustainability. So the main milestones in SEMSA, the first one and the big one started in 2015
when we carry out the transition in production from strip lengths in silver to coil production. So now our starting raw material is a big coil of 1 ton of 20 millimeters thick by 330 millimeters width, and from then we start the production. The following year, in 2016, we had a fully automated first silver bullion line focusing the 1 ounce production. In 2017, we introduced also automation, mainly in the weighing system, in the gold commemorative line. In 2018, we carry out an evolution of the fully automated silver bullion line. We improved the weighing system. We went from 2 decimal position weighting to 3 decimal position weighting. Also, we updated the automated visual inspection system to reach a capacity of 40,000 pieces per shift. Okay. In the following year, in the following years, we introduced also automations in the load and load of the conveyor furnishings and packing systems, and we carry out an extension of the blanking workshop. We added 1,500 square meters of useful surface. In 2021, we introduced in this new extension, we introduced a second silver bullion line, more flexible in terms of weight and sizes. In the last year and a half, we have invested in the automation of the gold bullion line. Same transition, we started with strip lengths, and now we are working in gold with coil to coil. So the first silver bullion line, one of the main achievements was the laser gauge measurement. We commissioned a micro epsilon continuous gauge measurement system with 3 decimal position. This allows us to real-time adjustment of the finished coil-to-coil rolling mill through 2 transversal gauge measurement. The weighing system that we introduced in this line is a Ford Mettler Toledo scales with 3 decimal positions and with a capacity of 45,000 pieces per shift, allow us CPK data calculation. The system, after weighing and remain, incorporates a 2D visual inspection system through 6 cameras. The technology is a photometric stereo 5D, and the estimation of the blank surface geometries with 6 different light conditions. The system incorporates 2 industrial PCs with a capacity of balancing the 45,000 pieces per shift. At the end of the system, we have incorporated an automated stack packing, and we, as you can see in the video, and normally we are supplied 250 pieces blisters. The next evolution is the silver bullion line 2. On this line, we were looking for flexibility because the silver bullion line 1 was focusing 1 ounce, range of diameter from 38 to 40 millimeters. In this new line, this allows us working with a diameter range from 5 to 65, allow us multi-shapes, triangle, squares, 5-sided, 6-sided, 7-sided, We are also using this line for fine silver blanks for bars, minted bar productions. It's designed for 2 ounces, 1 ounce, and all the fractionals, half ounces, quarter ounces, 1/10 ounces. The weighting system is through 8 Valanco scales, supported by 2 Yaskawa CX6 robots. There are 3 decimal positions weighting, with the whole range from 0.5 grams till 5 ounces, and with the multi-shape capability that I mentioned. This system incorporates a new visual inspection system based in deep learning technology. This technology is based in an advanced neural networks to learn patterns with different lighting position. And the good thing of this system is that works very well with the grace area, with the borderlines defect. You don't need to reprogram the system. You tell it how many are good, how many are wrong, and the system is able to learn by themselves. Okay. The next line was the same transition for the gold bullion production, the transition from lens to coil production. Again, diameter range, we were looking for flexibility because we are using this line for blank coins, not only round, if not also for blanks for bars production, so allow us to weigh the square, 5-sided, 6-sided, and is designed for weights like 1 ounce, 2 ounces, and all the fractional, half, quarter, 1/10. The weighting system is an evolution of the one that you have seen in the second bullion line. Again, there is 8 Valanco scales, but with 4 decimal position. This was the challenge of this line. So, in order to get the 4 decimal position, we need to commission 3 layers of isolations against vibration. So the system is able to weight from 15,000 to 25,000 pieces per seed, depending on the weight range. Weight range from 0.5 grams till 5 ounces, and fully multi-shape capability. At the end of the system, after the reaming process, we have an automated packing in plastic trays. Also, we have applied automation in the gold commemorative line. This was the first robot that we commissioned in Sensa because of the shape and the color is known as the Minion. And it's a 3-axis Delta robot that incorporates 2 Medley Toledo scales, also with 4 decimal positions, in order to guarantee to the customer the 3rd decimal position. Again, 3 layers of anti-vibratory isolation in order to have a capacity of weighting from 15,000 to 20,000. We are now in the evolution to fight those zero industry, sustainability. So now we are in the process of an integral digitalization of the integral digitalization process of the whole site for materials, production, quality, maintenance. I'm gonna, Now, okay, so we commission also thinking about sustainability, a 485 kilowatts solar panel plant that is giving us as an average in the year of 35% of the total electrical energy consumption of the site. And we are in a process of, we have a project in place in order to measure the carbon footprint on any single coins. So thank you very much to you all, and I'm waiting your questions.
So thanks to all the presenters for their work, for their hard work, and for presenting, of course. We had the topic inspection, security, and coin blanks. And you have been active, of course, in putting all the questions in Slido for us, and for a very active Q&A session. And lady first, Christine, the first question is for you. Coming from Thomas, could this technology used as well for plated blanks when speaking about defects such as blister, bubbles, or crackings at the rim?
Yes, because we can see all the damage, like notches or scratches in the as the reflections in the image. Like we can see the symbols in the same way. And so we can also detect damage in the surface. And our software is designed that we can very flexible define our areas of interest. For example, we can also define an area of interest over the whole edge area. And we can take all our algorithms we have already implemented for the existing 2D system to take these algorithms for the edge inspection, looking for example compact defects or distributed defects, scratches, and so on.
Thank you very much, Christine. Thank you very much, Christine. Next question goes to Eric. Eric, thank you very much for your presentation. How many minted coins have to be learned into your artificial intelligence software to create the golden sample?
A golden sample, well, okay, I understand the meaning. Okay, so a minimum of 100 samples for learning and 100 for validation. That's the minimum.
Thank you.
Next one is for Thorsten. It reflects the Overin technology. Isn't the world's first coin with a digital certificate embedded in the product the 2023 Eiffel coin of Monnaie de Paris?
Yeah, I think the Eiffel coin is connected via NFC tag, I know. So the difference is that we have not a coin without any additional part, and Overin is only an optical code which is integrated in the tool or in the printing. So we have no change of the material itself. So it's 100% precious metal. So it's no integration into the coin, it's just an application on the top of the coin via an optical code.
Thank you, Thorsten.
Thanks, Thorsten. Christine, the next one is for you. Your system is effective to identify letters and symbols for errors. Are you able to detect edge defects such as scratches, dents, or damages?
I understand that the question has the same content than like the question before. And so for short, yes, we can detect damages.
That was short and sweet. Thank you.
Thorsten, you still have to answer questions here on the Slido. Can the technology be used for circulation coins as well? How can the code be read in case of coins if the coin is getting old, dirty, or the image is worn?
Yeah, we have also made some tests with circulation coins because we have not that amount in production at Roy Company. We have used a Schuler press and MRH 150, and we tested this also. And the code is it is designed in a way if 20 to 30% is lost of the code, it is also readable by the application, by the app. But to verify if it's possible or how big the amount of production slots could be, it must be tested again for the case of circulation coin production.
Thank you, Thorsten.
Thanks, Thorsten. Eric, the next one is to you. How many coins can be scanned per minute? Question raised from Thomas Riem.
As on all our VISIA applications, the speed depends on the diameter of the coin. So we always make sure that we have enough processing power to go at the maximum speed, which roughly calculates as 800 divided by the diameter of the coin. So yeah, for a short answer, for a 20 millimeter coin, it's 40 coins per second. For 10 millimeter coins, it would be 80.
Thank you, Eric.
Christine, Alex wants to buy a machine and he wants to know which diameters can be inspected with the edge inspection.
Which diameters?
Which diameters can be inspected with the edge inspection?
Yes, we can inspect a range of 20 millimeters, and we can adjust it to the needs. For example, we can set the system to 15 to 35 millimeters diameter, for example.
So it's 15 to 35 millimeter in diameter.
We have a range of 20 millimeters diameter, and can adjust that the system that the system can measure coins or coin blanks from, for example, 15 millimeters and up to 35 millimeters diameter.
Okay, thank you.
Goran has raised a question to Overeen. How is the code protected from regenerating or copying? Can its presence be detected by some means other than Overeen app? And I'm suggesting that you don't do the whole presentation again, Thorsten.
No. So if you copy, for example, the coin or the tool, you can scan the copy on the paper, for example, but it's not possible to reverse it on another tool. So we tested this also, and maybe there are in the future some technologies, but at the moment only a copy is not enough to make a new tool for copying it.
Thanks, Thorsten.
Yeah, I just wonder, I think we had that question, but this is a repeat one again for Christine. What range of diameters and edge thicknesses? Yeah, here now the edge thicknesses can be inspected.
Yes, I told you that, for example, 20 millimeter diameters for a range of 1 millimeters to, for example, 3 millimeter thickness. But these two values depend a little bit from each other. What you need? Do you need more thicker coin or coin blank inspection? Then you can decrease the diameter a little bit. or you do not need that, then you can raise up the range of diameter. So for example, 15 to 35 millimeter diameter from 1 to 3 or 4 millimeter thickness.
Thank you, Christine.
Thanks, Thorsten. Another one for you. How does your code work? Does it work with the arrangement of lines or similar geometries? Why is it invisible for our eyes?
Top secret now. So it's an optical solution, so it doesn't work with lines, but you have just to imagine like a QR code. Yeah, it's or like a cloud of dots. You know, for example, from the iPhone. So it's implemented very small dots in the design, and yeah. So it's like an optical code which is integrated in the specific design of the customer.
Thanks, Thorsten.
Yeah, for Kim, Korean Mint, the question came from Shenyao Li. How would you compare the sintering shaped blanks with the performing blanks by mechanical stamping in terms of efficiency, quality, and costs?
Could you tell me again? Could you tell me again? I didn't hear about fully.
Shall I repeat the question?
Yes.
Yeah. So the question is how you compare the sintering shaped blanks with performing blanks from mechanical stamping. So the difference of sintered blanks and stamped blanks, mechanical stamped blanks, in terms of efficiency, quality, and costs.
You can also say you have not compared it. I think that will save us 5 minutes. And we have also Shenyao invited to talk to you directly. Shenyao, would you be happy with that? Because I think that takes another 15 minutes. Is that okay, Kim? Did you understand? Shenyao wanted to know about the comparison between sintered and stamped blanks with regards to efficiency, cost, and quality.
You mean the general blank and the sintered blank between?
Correct.
Quality?
Yes.
Yes. The relief is very high of this sintered coin. So when we make a press on the general blank, it is hard to form that high relief with very thin plate. So the deformation must, sintered blank has some pores in the blank, so it can be more deformed relative to the general blank. So I think I don't know, I'm not sure, but it can be possible with the general blank to form the intercoin level of high relief, but it is very hard to, because the press load must be very high, so the die cannot injure that, I think. So it is more better to make a intercoin level high relief or very thin. The sintercoin, the sintered blank must be. I think it is better than general blanks more. Yeah, I don't know this answer is sufficient for you, but.
Kim, absolutely 100%. You have tried very hard, and we all understand seriously that it is not so easy to compare a sintered blank to a stamped blank. Also, Shenyao, I guess, knows that, and it's depending on the relief and kind of product you are making. Of course, there are pros and cons, and thank you very much for taking the effort to answer that question.
Thank you.
Should we, Dieter, go along with one more question for Raul?
Yeah,
because
sure.
we do have really a number of questions. Raul, this is for you. What are the next steps in automation, if there are any?
normally we are applying automation on the critical parts of the process. So, for instance, the bottleneck is what gives you the output of a balanced automated line. So, for instance, we have been working during the last 2 months in a buffer system. It's not presented it's not in my presentation because it was commissioned 2 weeks ago. Between the blanking press and the waiting for now is our bottleneck in the line, so the waiting system should not stop. So we have introduced a buffer system with a robot that is stacking the blanks. So, for instance, when we change the coil for feeding the blanking press, the waiting station is not stopping, okay? It's always working. So, it's an example, okay?
Thank you, Raul. We all understand that the more automation, the better, but also you need the mass to be ordered, to be produced in those ranges. Thank you.
Yeah, friends and colleagues, there are a number of additional questions, but I feel, and perhaps you feel as well, we should look a little bit on the timing. We have another block in front of us, and again, coffee is waiting for us as well. And desperately listening to 5 presentations is quite challenging for everybody. But before you go for a coffee, you give please a big hand to the presenters. We thank them very much for all good efforts. And you all have been active in asking the questions, so you deserve a break now. We are a little bit under time pressure, so listen to the gong and please rush back to your seat for the 3rd and last and final session for today. Thank you. Can we have the teaser, please, Julia, for the next presentation? Yeah, and here we are, and with me on stage is Dr. Hai-Lin Sun. He is not the first-time presenter. He is a regular there, and later I will show you some slides of the past years. And Hai-Lin was here at the Technical Forum very often and also presenting. And today's topic is, of course, the PVD carbon coatings with magnetron sputtering technology, especially under the experience and testings they have made on copper nickel coinage stamping dies. Hai-Lin, the floor is yours, and the applause as well.
Thank you very much for your introduction. Almost good evening. It's quite late in our session. Yeah, today's topic is really about called PVD carbon coating with magnetron sputtering coating, especially for copper nickel coins, because as you know, we develop a lot of coating for different applications. But copper nickel always called people mention that they have issues. Today's called, let's say, topic basically introduced called tier coatings first. Then we talk about a little bit PVD magnetron sputtering technology. Then we give a little bit called property of the carbon coating. Then how we develop this kind of coatings. Also, copper nickel material, they have some issues. What is solution? What is achievement? finally, we work with our Mint customer, which have some kind of customer trial. Then I will summarize all the things for the research. A little bit called the introduction for tear coating. Maybe someone is new, so just let you know tear coating, which is founded by Dennis Tear. This is why tear coating name from. It's from university, so research is a very is a key course called things is tear coating. We have 25% people which have PhD degree develop PVD coating. During history, you can see we have a lot of world famous pattern. It's called closed field embarrassing magnetron spotting technology, which is well known. Also in the middle, if you really see kind of highlights, we have called MOC coating for space industry. We also have a carbon coating. This is I'm going to talk about. Also, we have DLC coating as well. In the middle, tear coating belong to the part of a big group called Amoeba. So this was a lot of coating machine in Mint industry, still logoed Amoeba. But 5 years ago, we become independent, especially develop other new technology. Last year, I presented called linear source technology, which is great for cleaning. And now we also could produce new coating as well. Mint industry basically just part of the tear coating business, around 10 to 15% of the revenue. We actually sold a lot of machines around the world. For Mint itself, 40 coating machine, which is installed. You can see the map where we are. So all the Mint have our coating. Commercial stuff finished. Let's go to the technique. This is something I sort of would like to emphasize. Why is it called surface engineering is very important. Because as we know, it's called a famous language, God makes solid, but surface always have someone damage something. For example, you damage the surface, the whole thing's basically thrown away. Also, surface you can create a lot of new surface, make a lot of new function as well. So this is why surface is more important than called the solid material. Especially current now, it's called surface engineering. From 18th, totally developed. This is why called the PVD technology. At that time, it's introduced in the Mint industry. What is called the magnetron spotting technology? Basically, it's called a vacuum state. We have some kind of working gas introduced. Then ionized called a working gas, which is have energy to impact. It's called a target. Then it's sputtering some material. The material will transfer to the path in the Mint. You dye a lot of things. Then you produce coating. It's called a pure metal coating. You can produce. Also, you can introduce called a reaction gas as well, nitrogen, oxygen. Then you grow up the coating. This is why coating have a special property. For mechanical coating, very hard. Also for some kind of solid liquid coating, you have low friction as well. The key secret is called the magnetron. If you see the left side, you can see behind the target, you have lots of magnets. This is a know-how about this called mechanical things. This is why when you develop different coating, you need a different magnetron. Yeah, this is a very famous coating called technology from tear coating. You can see all the magnetrons, they linked. Then you can produce a very good coating. So I'm not going to the technical part. The most important things, you have 4 magnetrons. Most of them, you have this kind of tear coating machine with 4 magnetrons. You can put a different material, different metals. Then you can generate a different coating. This is the flexibility which the tear coating produces. Then you can do the study by yourself. This is called we sort of coating selection for our Mint industry. You can see we have titanium nitride, we have chromium nitride, we have a chromium aluminum nitride, we also have chromium titanium nitride as well, titanium molybdenum nitride. They all used by different means because application is different. This is why you need some solution. You need a tailored coating as well. Today, I generally want to talk about the highlight one. It's called Griffith coating. What is special about this coating? If you really look at the right side, it's coefficient. For a lot of hard coating, the coefficient is very high, 0.5. But if you really look Griffith coating, only 0.15. It means it's a very slip coating. Why it's important? Of course, a lot of developer things that we ignore. Because when you do the stamping, when the dye is touch to the blank material, actually the material move. If you have a low friction, it means move is much easier, so no damage. Also, because when you have a different design, so the material can move to in some corner. This is why makes the quality very good. Secondly, as well, it's color, which is cutting edge. Because if you have a lot of things stick there, so this kind of debris will go into your press process, damage your quality as well. This is called special for the copper nickel blank. They have this kind of big issue. So this is when the customer come to us, say, Hai-Ling, we have some kind of stickness issues. Can you solve this one? Yeah, we have your machine, we have other people's machine, but they all produce these kind of things. This is why we said, okay, we do a little bit of study because we have a lot of history, have a carbon coating. A little bit academic stuff. If you really look at the left triangle side, there's a carbon, they have some kind of structure. From bottom SP2, it's called a graphite structure. You can reference to the right side. So SP structure, basically called a layer structure. If you go to the top, basically called a diamond structure. Real diamond have this kind of structure, but diamond is too brittle. And graphite is very soft. If you hold the battery in the middle, you can see this kind of thing. But they are very slippery. They are very good for the solid lubricant coating. But in the middle, you can see a little bit up, SP2. We can create a lot of amorphous called carbon. Put a little bit of hydrogen, become called, let's say, diamond-like coating. This a lot of people mentioned. But why we are not going to the diamond-like coating and go to called pure carbon coatings? The reason is called a healthy safety issue, because when you produce a lot of called diamond coating, you need using carbohydrate gas, which is a lot of companies don't allow. Also, you need to put a lot of safety device, to prevent explosion. So this way, also because our machine already sold 40 in the world, we can adopt something, our coating. This is the original coating we developed for automotive industry, Formula One, fuel injection, even called for the airplane as well. This is why based on this coating, we started called a little bit of treat. If you really see the coating properties, thickness only 2 micron, hardness is 12 to 18 gigapascal. Coefficients you can adjust from below 0.1 to 0.5. It's really already can be used for minting industry. The coating process is to be very simple. You can using gas called plasma clean, or using the technology I mentioned last year, linear source, clean the surface, remove a lot of things. Then you put the addition layer. Then you put the transfer layer and finally produce the coating. It's done. It sounds very simple. But in reality, of course, a lot of study going to the microstructure, going to, let's say, how to change the layer structure to particle structure, or you can build multi-layer things. If you guys are really interested, the paper you can read. It's quite a long paper. Maybe too boring for other people, but for me, 35 years in this area, I found it fascinating. Yes, go to the next one. Because when they mentioned the copper nickel, this kind of material, they have issues, but we need to test from our test lab. We're trying to buy a lot of copper nickel zinc ball. It's called the things we can do a lot of testing, but unfortunately we cannot buy this kind of things. For the commercial available is the copper zinc, which is similar to this. There also some mint use this one as well. Very sticky, very nasty material. So then we do some tests. It's called a standard coating test, called a pin-on-disc test. We can test the friction is one thing. Also, we can test a little bit of thickness as well. You can using round one, it's called pin-on-disc, or using let's say, rubber one, like move this kind of way, then you find out what is the issues. The results come to very interesting. First, of course, if you see the, let's say, gray one, titanium nitride, which is common used by mint industry. When the rubbing test start, the coefficients start going up to window stage. Also, a lot of people using chromium nitride as well. So when you see the chromium nitride coefficient against copper nickel, copper zinc, let's say both, you can see the friction stable, similar like end of the titanium nitride coating. But if you using graphite coating or carbon coating, you can see the friction is much lower, which is in here, you can see the number is not big, but in reality, because you repeat a lot of things, you will find it's have some benefit. Really, we also check the rubbing test, let's say, coating side. You can see from titanium nitride, a lot of copper zinc material stick on. Chromium nitride in the middle and the graphite coating is the best. Then you check on the let's say, copper zinc ball as well from bottom. You can see actually the low friction coating, academically we call the solid low friction coating, basically protect your things, for the right titanium nitride, you can see a lot of scratch. And also in the middle chromium nitride, less a little bit, but still have wear a lot. But graphite coating really smooth become. This is a big benefit. What about the customer trial? This is the first one we, of course, work with Xianyao Li from Royal Canadian Mint. Test, they are called test die. We just using the original PVD titanium nitride, plus we supply them coating 1 and coating 2. Coating 1 and coating 2 is top is a graphite coating. At the bottom, we change a lot of things. We may have another coating underneath as well. Xianyao Li's Royal Canadian Mint test results. If you see original titanium top left, it's just it's not clear. A lot of things move the right is using graphite coating. You can see the clarity is much more. This is from SEM back spotted results. Also bottom as well, if you see the uniformity between the two coating, left is titanium nitride coating, and the right is a carbon coating on top as well. So immediately you can see the uniformity is improved as well. What about the lifetime or in real production? We also worked with Xianyao Mint from China as well. They bought our CF800 system, mainly for chromium element titanium nitride for numismatic coins, also a little bit proof coins as well. So additionally, they asked us for greater coating. So we did some thing compare with traditional Tian coating from one company, which is not from us, and plus DLT coating, graphite coating as well. First, of course, coating life duration, similar, I would say, 40K to 50K, because then they stop, it's just a move. The major difference you can see, repolish interval period. Because the thickness of the coating, normally after the 1,000 to 2,000 things using traditional coating, they have to little bit clean, polish a lot of things, then come back to restamping. But with graphite coating, 5 times longer, immediately you can see. This is why basically efficiency, and you don't need to change your die often. This makes things different. Quality as well. If you really look at the right bottom side, for titanium coating, when you start stepping a little bit longer, you find a lot of let's say, star burn or scratch things. But for the graphite coating, never have this kind of problem. So this is why coating, let's say, damage quality is improved a lot. This is why it's basically the graphite coating is successful using for products due to, if you can see the products on the top is already sell in the market. Yeah, it's just summarize our this talk. Basically, PVD coating, titanium nitride or titanium plus a lot of things, and the chromium nitride plus chromium metal nitride things, it's already widely using for a lot of application for mint. It's just we add another coating, basically trying to solve your thickness issue. This is something we will do, for us called solid lubricant coating, DLC graphite coating. Even today, someone mentioned titanium diboride actually in our catalog as well. We can offer some little bit called low friction coefficient against the copper nickel conjugate material, which is give another selection of the coating you can use. Because at the end of the day, for me, the message will be it's like a medical stuff. We find your issues, or you tell us where you are pain, we find the solution for you. It's tailored. It's not just you give you some kind of one coating like paracetamol, solve your issue. No, for me, the best things you give are called a tailored coating. Of course, with our test results, we have a copper nickel issues, which graphite coating can easily solve this problem. And also, the reason I mentioned why we don't go to the DRC, because health and the safety issue is a big concern. This is the reason we stick on the carbon coating itself, simplify, meet customer need, and go forward. Of course, we have to thank Royal Canadian Mint, Shenyang Mint, and also our university partner, especially called the R&D team. I'm the leader. They do a lot of work. So this is why I have to thank them to this one. Anyway, it's finished my today's talk. Thank you for your attention.
Alan, we have to thank you because I know you can be diving much deeper into the ocean, and we are very happy that you did not do that, because otherwise it would be very hard to follow all your experience and your technical knowledge. Thank you for being here.
Thank you. I followed your instruction, make it simple.
We have not been threatening you. Please take a seat.
Okay, thank you.
It's interesting. We should show his presentation when he started. I think we all would just fade off, not understanding he has so much knowledge. Sorry to say that, Helen. The next presentation is from the Bull Mint, and we would like to have the teaser, please.
Hello, and good day, everyone. Today, we would like to speak with you about precious metals and their production. Precious metal products, such like our recently issued Phoenix bullion.
Welcome, my name is Maya and I will show you how it's done.
Very impressive, isn't it? I think you are curious now. We would be pleased to share more details with you during our presentation at the Technical Forum. We look forward to seeing you at the World Money Fair in Berlin.
Both Thomas and Maya have explained that they hate to hear their own voice and see them on the screen, but this is what you do when you do teasers. Thomas, no need to introduce yourself. Maya, you are taking over almost the whole production at the Bull Mint, and you are very close to do so. And today you are happy to reflect your experience about refining. Thank you very much.
Thank you. So thanks a lot, Thomas, for the kind introduction and for giving us the opportunity today to speak about Bull Mint's approach for a closed cycle. First, we would like to start with a few words about our company, who we are, what values we stand for, and how we continuously push the boundaries to the bullion industry through an unwavering commitment to produce the highest quality products modern technology is capable of. Bull Mint is a private mint, smelter and refiner based in Plovdiv, Bulgaria, a region in Eastern Europe with a rich history of gold workmanship spanning 6,500 years, home to the oldest crafted gold objects ever discovered. As successor to this legacy, our mission is not only manufacture, but to set new standards for quality, artistry, flexibility and innovation. We are a manufacturer of high-quality investment and collectible products made of the finest gold and silver, such like blanks and bullions with proof-like finish, bars of any weight, and collectible proof metals. We believe that in order to ensure that the execution of each project lives up to our exceptional high standards, every stage of the production process must be in our own hands. For that reason, in 2023, we finally closed the gap and we established our very own gold refinery. This gave us and our clients the assurance that every aspect of the production is in our hands of proven experts equipped with the finest technology in the industry. Now we will show you what methods we use to produce our products at the highest quality technical level in order to meet highest possible quality standards and respecting cost efficiency in a complete closed in-house cycle. Refining and casting, how Bullmann closes the entire process. And now I would like to pass the stage to my charming colleague Maya, who will immediately and noticeably rise the level and have fun now with her commands of the topic refinery.
Thank you, Thomas. Good afternoon, ladies and gentlemen. I'm really flattered to be able to present in front of all of you today. We're going to introduce you, in simple terms, the concept of refining. By the end of this presentation, you will know the answer to the following question. What is precious metals purity? How can we achieve the purity of minimum 99.99%? Why Bullmann is expanding its operations with precious metals refining? Generally speaking, refining is the act of processing raw materials that contains precious metals inside in order to remove any impurities. This takes place in several stages, which I will explain to you in the next few slides. I will guide you through the process of refining gold to a purity grade of 4/9, which is one of the highest in the industry, with an impurity content no higher than 0.01%. Here is a main scheme showing the whole refining process. The raw material is proceeded in two refining stages, chemical and electrochemical. Each of them is carried out in closed-type refining systems, which have an additional advantage. Both systems can be used separately depending on the content of the primary material. This is the visualization of the chemical stage. As you might see, the raw material is dissolved in aqua regia, which is a mixture between nitrate and hydrochloric acid. This so-called chemical purification causes the gold to be precipitated in form of gold dust or sludge, with a purity of around 99.5%. For this reaction to work, the minimum amount of gold that should be present in the raw material is 80%. The higher the gold content is, the faster and more effective are the processes of dissolution, filtration, and reduction. There are certain parameters which we must constant control during the refining process. A few of them are the reaction surface. The total reaction area is a very important process for the process to happen. The bigger the reaction surface is, the better. The ratio of chemicals. The ratio of chemicals used in the process is also very important. Any mistake or miscalculation may result in the reaction to fail. Very important parameters also are the temperature and the stirring speed. The goal of the chemical stage is to extract the 99.5% gold sludge so it can be refined further during the next stage, which is the electrochemical stage. 99.5 purity is the threshold above which the electrochemical stage can start. In simple words, the refined material is already with the desired purity that allows the fine gold to be extracted. As it's shown on the scheme, the process is electrolysis based, but before it can even begin, the gold sludge needs to be pre-melted and prepared properly. Here again we have some parameters that need to be strictly controlled during the reaction, like the temperature of the working solution, the concentration of gold in the electrolyte, the qualitative and quantitative composition of the anodes, like surface area or density. Also, the presence of impurities in the electrolyte is very important to control. By the end of this stage, the gold has reached the desired purity grade of 99.99%. Here again, you can see the whole scheme of the both stages of refining process. Now, some of you might be wondering, what if the material has gold content less than 80%, which is the required minimum for chemical purification via aqua regia? There is more than one technical solution to this problem. One of them is the pre-separation of gold from impurities via dissolution in diluted nitric acid in process called inquartation. The main requirement for this process is 30 to 70 gold to impurity ratio. The 70% needs to be soluble in nitric acid, and in the best case scenario, this part will be silver. As a result of the inquartation process, the gold is precipitated in the form of insoluble residual. In order for the refining process to continue on to the next stage, the residual needs to be pre-melted and prepared again. When we are doing chemical reactions, we cannot allow not to speak about sustainability. The process that I have presented so far can be done without any chemicals or emissions. So this naturally brings up the question, how do we interact with the environment? And the answer is, in perfect harmony. We approach every aspect of our operations responsibly. I already mentioned that all refining operations are done in closed-type systems. The emissions from this process are contained and neutralized in scrubber systems, and the sewage is collected in chemical storage bunkers, which are periodically submitted for disposal. This ensures a safe work environment and full environmental protection in accordance with our active ISO standards 14001 and 9001. Speaking of standards, how can we guarantee the quality of our products? One word, control. Getting reliable results in the analysis of precious metals and other chemical elements is crucial to making adequate technological decisions and to certificate the quality of our final product. Behind the word control stands a flexible organization, a closed in-house production cycle, and a team of highly educated experts. Integral to the quality of our operation, not only refining, but every subsequent stage of the production is our chemical laboratory. We apply analytical control at every stage of the production cycle. Strict quality assurance provides a steady foundation for all technical solutions across the manufacturing chain. Now, speaking of production, I'm going to pass the stage back to Thomas so he can shed some light onto the next stage of the production cycle, casting.
So thank you, Maya, for this fascinating exposition. I'm sure the audience would love to hear more during the Q&A session. Let's continue and delve into the next process step of a precious metals journey, the casting. Once the metal has been Once the metal has been refined to the desired purity grade, the cycle continues with the casting. In very general terms, casting is the transformation of liquid molten metal into another desired shape. This can have the following reasons. To produce a new mold, which is required for further processing, and to produce new alloy to achieve new desired physical properties. Basically, there are three different methods when we talk about casting: mold casting, continuous casting, and vacuum casting. Coming to more details. In the spirit of tradition, I would like to begin with the most classic form of casting, the mold casting. First, a brief definition. Mold casting is the process of pouring metal into a pre-made casting mold to give a desired shape for products, among others, bars, blanks, or any other desired form. The desired weight is determined using granules with minimum blast tolerance and melted at over 1100 Celsius degree in case of silver and approximately 1250 for gold. During the pouring, the constant flaming ensures an even surface appearance. At Bullmint, however, blanks up to 1 kilo and in individual cases, even larger ones, are manufacturing using the same molding process, which represents a significant difference in quality compared to the otherwise common sintering method. Mold casting results in a higher level of homogeneity and more control over the crystal structure, and helps to avoid formations of voids, lunkers, and inclusions. In this very complex process, the desired weight is casted with a significant blast tolerance. The blank is compacted by forging and then brought to the final weight through several steps of mechanical processing and subsequent partially manually polishing when the surface is made to be shiny. Continuous casting. Continuous casting is a method wherein molten metal is solidified into a semi-finished shape for further rolling and milling. Modern technology has allowed us to automate this process for improved efficiency. The technology shown in the picture could be used for pipes, wires, profiles, and for sure as well for strips. First, the bars, granules, or other raw materials that are to be processed are pre-melted in a so-called ladle. This mass is then transferred step by step into the actual crucible. This is opened downwards, and the metal that begins to solidify is formed in the desired size by a so-called kokile. The strip is continuously drawn and further cooled by water. To achieve the best possible surface for the further rolling process, the surface strip is milled off on both sides. At the end of the process, depending on your wishes and needs, you can cut it into individual pieces, or, if process is automated, the strip can be wound up again in a so-called coiler. At Bullmint, we have a total of 3 of those systems. This allows us to respond to any customer's request, no matter whether the focus is on the purity of the material, the alloy, or the cost efficiency. Vacuum casting is the process of molding metal under a vacuum. The process is particularly suitable for applications with the highest demands. Purity, as graphites or other foreign materials in particular, can be avoided here. Mintability through perfect recrystallization and no oxidation at all on the surface. High melting temperatures of up to 3000 degrees are possible. This not only enables us to process gold and platinum of the highest purity, but also corresponding desired alloys. Coming to our conclusion. Today we studied the most essential stages of precious metal production, refining and casting. At the starting point of every cycle, by opening our own refinery, we close this cycle. This model brings a number of benefits: a higher level of precious metals extraction, more flexibility, and, last but not least, a high economically efficiency, which all affects the most important cornerstones of a positive customer's experience. Before coming to the end of our presentation, I would like to take the opportunity to say a few additional words. This year, both Bullmint and the Technical Forum celebrating their 20th anniversary. This is an appropriate moment to say a big thank you to the organizers and moderators of this popular format. Thank you for your never-ending commitment, your efforts, and I would like to mention this as well, also thank you for your patience with some of the presenters. And after now we have talked so long about liquid gold, not only by me, by Xingyao as well, here's a little sample of it, which will help you, among other things, if some of our colleagues have overextended your nerves. Thank you.
Thomas. Thank you, Thomas. Thanks indeed.
Oh yeah, thank you very much. We hope there is no compliance in this room. We'll take it and drink it. Thank you very much.
Thanks for your presentation, and please have a seat and join us for the Q&A session.
Thanks, Thomas.
Well done, and looking forward to see all the questions in the Q&A, and thanks for the goodies. We will taste that to all our healths later. Can we have the next teaser, please? dear friends and colleagues, once more, first-time presenters here on stage. We have the Germania Mint with us. Szymon and Jakub have a topic which we didn't have before, and it took long till when Thomas and myself did read the abstract to have them on stage today to talk to you about the next step of selective precious metal plating. So, gentlemen, the stage is yours. And please give them a big hand. Thank you.
Ladies and gentlemen, partners and friends, this is my first public appearance in front of such a great audience. I count on your understanding. Today I'm pleased to present to you the recent progress achieved by Germania Mint in collaboration with Imago Printer in the evolution of selective metal coating methods. Our presentation will delve into various key aspects outlining the journey and innovations that we will hope revolutionize the field. We will begin the Germania Mint pioneering achievement in precious metals coating technology and Imago Printer groundbreaking contribution to printing methods underpinned our shared success. We have named our project Germania Mint Technologies. We wanted to be the start of a path that we will allow the whole numismatic community to develop the quality and attractiveness of of mint products. My name is Szymon Kurowski, and I've practically grown up immersed in the world of numismatic products. Today, I proudly hold the position of CEO and founder at Germania Mint, a company with over 250 employees, tracing its roots back to a numismatic shop founded by my father nearly 40 years ago. Joining me to shed light on our project is Germania Mint Chief Technology Officer Jakub Zawistowski. Jakub has been instrumental for 14 years in spearheading technological achievement within my company. Firstly, let us share the origin story of our collaboration. Then we will take a quick look at the current method of selective plating with noble metals and examine what areas we can enhance. Next, we will provide an overview of our next technology and its advantages compared to electroplating methods. We will showcase several application examples and the outcomes derived from our test and research. Finally, we will gaze into the future and discuss what the Germania Mint Technologies project entails. Germania Mint has earned its reputation through extensive research and development initiatives aimed at enhancing coins, pioneering inventive solutions, and leading the way in innovating coatings. Throughout its journey, Germania Mint has constantly prioritized innovation and the exceptional quality of its offerings. Notable, Germania Mint isn't just recognized for its commemorative coin releases, it has also collaborated with mints worldwide, delivering cutting-edge solutions on a global scale. Moving on to Imago Printer, it stands out as a premier Polish manufacturer specializing in digital flatbed printers, renowned as a trailblazer in UV LED technology, durable printing on anodized aluminum, and even food printing. Imago Printer has solidified its position at the forefront of the industry. Drawing from years experience and steadfast dedication, Imago Printer continues to innovate and develop advanced solutions. Within over a decade of experience, they had successfully established a robust market presence with their state-of-the-art devices now operational worldwide. Germania Mint and Imago Printer have combined their expertise and resources to develop a series of devices aimed at offering comprehensive support to the coin minting industry. These devices are designed specifically to enhance coins, representing a significant advancement in the field. Allow me to introduce Jakub Zawistowski, who will delve into the technology aspect for us.
Thank you, Simon. Thank you, Simon. Good afternoon, ladies and gentlemen. My name is Jakub Zawistowski, and I'm thrilled to share you into
the technology we developed. We tried to understand the current landscape and challenges faced by the industry. This analysis provides insight that have fueled the development of our technology. I delve this advancement shortly, but let's first understand where we stand today and some of the challenges we face in metal plating. High entry threshold, so building special laboratory, establish necessary equipment, chemicals, baths, and all the significant initial requirements. Complexity of the process. Most of our aware, the coin enhancement process is very complicated. It takes several processes to achieve the final product. Potential risk of damaging the coins. Each subsequent step is process carried to the risk of damaging the coins and the visual state of the coin. Repeated masking, and is it harmful for products? Generation of chemical waste. In total environment conscious era, we must carefully consider negative impact to the environment and strive to minimize it whenever possible. Long wait for prototypes, but also for production. Granting the time from the 3D model of the coin to the final product, it's quite lengthy. All operation and process need special personnel, making it challenging to find the individuals for the job. Of course, there are other challenges we face, such as precision of masking, especially for small detail, possibility of spot of the proof coins, and all the issues involved in ultra-high layer of coins. Understanding the challenge is vital as we move forward in our advancement technology and innovation. So what we can change? We can reduce startup cost. It will be great if we can eliminate need of dedicated laboratory setup and the costly equipment. Simplification the process to significantly reduce overhead expenses. By minimizing the step like masking, repetitive plating, washing, we can reduce the change of damaging the coins. Decreasing waste production. This not only benefits for our company, but also contributes positively to our plant well-being. Accelerating the process. Simplification can lead to a shorter processing time and hence its efficiency. Making equipment user-friendly. Imagine if this operation will be simply easy like press the button. At this stage, we arrived that what we call the next step. We have decided we condense the entire galvanic laboratory in a single machine. And I will try to explain you how. This next step is direct digital printing of the pressure, but not only pressures, metals into the coin. We employ nanoscale metals suspended in the carrier containing carefully selected binder, solvent, and other additives to achieve a special ink parameters like viscosity and surface tension. Then, using the specialized printer, we apply the layer of metal to the surface of the coin. Then process still requiring bonding the printed layer together in the sintering process. Here, depending on the ink, we can use the thermal, chemical, or photo ink sintering. After the process, the uniform layer of metal is formed. On this slide, you can see the accelerated sintering process. Unlike the application in electronics, where the electrical properties of the layer are crucial, we don't have to be concerned about these facts. So this enables the sintering process to occur in significantly lower temperature, which we have no impact to the coin themselves and allow to work with non-metallic materials. Here you can see one of the first successful tests after silver printing, and in this case of the copper disc. The measurement we took confirmed the purity of silver 4/9. A single layer has average thickness of half of the micron. Also, to be sure of the usability of the process, we conduct corrosion tests in humidity chamber as well in a neutral salt spray for almost 1,000 hours. The silver and the gold layer do not show any degradation of deviation from the reference samples galvanical deposit layers after this period. As today, we have completed silver and gold ink. However, we are still working on the additional metals like palladium, ruthenium, platinum, etc. The creation of additional inks are rather long and complicated research process, and we love to hear from you about the materials you are anticipating. Perhaps we can develop a special ink just for your needs. So what we changed in implementing this technology? We have a single machine, a much cheaper, that does require special structure, take much less space, and allow to quick and easy production scalability. The process is now straightforward as coloring. Single continuous operation, no need for washing or other process. We can use multiple metals of the single machine. Complete waste recovery, virtually no waste. All the nanoparticles used outside the coin can be recycled back in the ready for printing. Prototype under an hour. If you want to see how different elements is gold-plated, silver-plated, or whatever, no problem. Let's design and print it on the coin. This technology is incredibly user-friendly, allowing the printer just to click on the button.
At this point, I'd like to share a bit about Germania Mint approach to the rapid prototyping. After the design phase of the new coin, we produce a 3D print. Next, we coat it with the layer in copper and silver. Moving forward, we treat it as a coin, appliquing enhancement layer. Now, thanks to the new technology, we can add new plated elements on the fly. There's different solutions. Just let us imagination run wild and see the results almost instantly. Thomas and Dieter told me that I should have some lucky charm because it's my first time, and I chose this prototype as a real live proof of the next step. Thanks for this technology, it's been possible to achieve expectation in thin lines, about 0.1 millimeters. It's now possible to apply metal onto non-metallic materials and create tonal transition between the metals. All these advantages and new process comes to one thing, creating unique, modern, and breathtaking coin. I'd like to take this opportunity to thank everyone involved in Germania Mint technology project for their hard work and ideas. Thanks you, and passing the floor to Simon.
Thank you, Kuba. Today we are preparing a device for commercial deployment. I hope that at the next World Money Fair we will be able to show the finished device and demonstrate this technology to you live. However, before that happens, I would like to invite you to share your insights and reflection on our idea. Perhaps with some of you, we can initiate test of this technology on your products. Working with nanometal printing itself has inspired us to conceive a line of machines for other applications, like, for example, jewelry. As we focus on digital printing of precious metals, we are also in the process of developing a color nanosolvent printer. At Germania Mint, we have initiated pilot test utilizing nanosolvent printers developed by Imago Printer. Our R&D team has successfully engineered a white underlay ink, enabling us to achieve a unique color saturation. We are currently in progress developing a vision system aimed at achieving the superior quality that has long been synonymous with Germania Mint products. At Germania Mint technology, we firmly believe that this technology will supersede the old printing methods used for years. Germania Mint technologies aimed to be a support in your continuous development and quest for innovating, enabling solutions. Let's converse, share ideas. We have plenty, and I believe you too. Quickly summarizing what Jakub mentioned, for me, the most significant advantages of the new technology for selective application of precious metals are primarily faster and more cost-effective production. It also offers new possibilities and creative support for our product development department, all while emphasizing environmental care. We invite everyone to visit our booth. If you have any questions or want to be a part of the project, feel free to contact Jakub. Thank you for your attention, and I invite you to engage in discussion.
Simon, thank you very much for sharing this technology and also to sharing an inside view with the Germania Mint. As you have been here the first time, we really appreciate that you were coming. Thank you very much. There's actually enough chairs if you want to sit there as well. You can do that if you want. Jakub, thank you very much. Well done. Talking about innovation, actually, I did not know that the Portuguese Mint has an innovation manager, and that is your title, Sonja. I really like that. So you only have to handle the innovations and see which ones you are doing. This is what we learned. Let's have a look at the teaser from Portugal.
A NCM convidou o artista Bordal II para desenhar a terceira moeda da série Arte Contemporânea Urbana. E logo de início, quando nas primeiras reuniões que tivemos, o artista teve logo uma ideia muito concreta do que queria fazer. Os pressupostos iniciais foram sempre a moeda ter uma metade em prata, no metal habitual das moedas de coleção, e a outra metade ser feita num material menos nobre, neste caso o vulgarmente chamado plástico.
Uma das dificuldades que tivemos, uma vez que temos dois materiais diferentes, foi tentar fazer com que o cunho tivesse a gravura coincidente com o polímero, de forma a podermos encaixar o polímero sobre o cunho e depois proceder à cunhagem da moeda.
Esta operação era de extrema importância para que o metal, quando os cunhos exercessem a sua pressão no ato de cunhagem, o metal não expandisse mais do que necessário e que fosse ocupar o espaço do polímero.
We have been in Portugal. I've never hearing people speaking so quickly. Take your time now. Please do so, Sonja. We are looking forward to that very interesting title of Commemorative Biomaterial Coin from the Urban Contemporary Art Series. Stage is yours.
Thank
you.
Thank you. So today, it's my first time here. As it's been said, thank you all of you for being here. Thank you to the organization for giving me the opportunity to be here and to show you the work of the Portuguese Mint. So the idea behind this series was to invite renowned Portuguese urban contemporary artists to design coins that would represent their work. The first coin of the series was designed by Vils, that is an artist that uses a technique of bas-relief carving to represent faces on murals, basically. He uses several different techniques. I have an example here that is one of the most impressive that he uses, that is with explosions. And in this coin, he represented, as you can see, in one face of the coin, it's an eye, and on the other face, it's his signature. In the second coin of this series, we invited Aka Corleone to design the coin, and he is known by using strong colors and also to share strong messages. And this coin was based on an installation that he has on a building, that is the middle image that you can see up. That represents of a man and a woman to represent equality of gender and of race, rights, and options. But the reason why I'm here today is to present you the third coin of this series, done by an artist that is Bordal II. For those who have been in Portugal and in Lisbon or Porto, probably have crossed around some of his art. So he's known for working with trash. What he does is to give a second life to materials that were no longer used. So I have here a few examples. These installations are all in Lisbon. This is not an usual day in Lisbon. Usually you have sunny days. This is a very strange day in Lisbon. But you can see in this particular example, you can be able to see the pieces of trash that he uses and the size of the samples. So it was really challenging to have an artist that works in such a big art and transfer that to a coin. So this was the challenge. When we starting the meetings with the artist, he had an idea to do a coin that would be half of silver, the usual materials, and the other half in a recycled polymer. And he had an idea to have a drawing of an owl that represents, how can I say, is smart and I don't remember the word now, but the owl represents wisdom. That's it, wisdom. So since we had to do half the coin in recycled polymer, and the artist requested three different colors with the design integrated, we started an innovation project to develop his concept, his idea. So the most challenging part for us, of course, would be the polymeric component, and we had an ID project with an external partner that has the expertise on this area. So what we had to do, first of all, was thinking about a technology that could have all these pieces equal in all the coins. So we did mold injection technique for this. And since we had three different colors, we had to build three different molds, one for the blue color. Then that piece was transferred to a second mold to inject the white color, and then finally to a third mold to inject the red color. All of this in a thickness of 2 millimeters, which means that each color had 0.6 millimeters to work, which is really thin. So before starting with the injection molding, we did some simulation. We used the software simulation to help us evaluate what would be the problematic areas that would result in defects. So that way we adjust the design in more sharp areas to avoid those defects. And we did this for all the layers, for the blue, for the white, as you can see here, and also to the third layer, the red layer. I have here a small video to demonstrate how the robo is extracting the polymer all with the 3 layers, so it's ready on this face. And after solving the problem of the polymer, we had to transfer and integrate the polymer on the coins, so we started to study how to do that. So we start by cutting the blankets. We did it by EDM, and we have to study the exact size of the cut and also the shape of the edges to accommodate the polymer. Next step that had some challenges to overcome also was the striking process, because although we had previous experience in bimaterial coins, we never had one with such a big area of polymer, and beside that we also had the design integrated, which means that during striking we couldn't damage the drawing that was already there. So we had to adjust the dies and have an intaglio to fix the polymer pieces in order to fix it and to avoid that he moves during striking, and also to avoid that we would damage the polymeric pieces. After that, and because the artist had the idea of, when we look at the coin, we could see half polymer and half silver, he suggested us to also do a yellow contour and paint that side of the coin in order to give that idea of having half of the coin in polymer and half in silver. So we also had to study several parameters to adjust the painting, to avoid to paint the polymeric areas, and we had to paint the high reliefs and the low reliefs as well. And as a result, we had this product. You can see it on booth C10, I think I'm saying it right, yeah. and you can go there and visit the coin, and we are very proud to say that this was voted as the favorite coin of 2023 with the Portuguese public. So thank you again, it was a pleasure to be here.
Thank you. Wonderful presentation. Please join us for the Q&A session. Have a seat with us. And friends, don't forget to put your questions on Slido. Looking forward for the later discussion.
Fits you well. Lukas, as this is a technical conference, what you did is not acceptable. As you heard from the audience. Thank you very much. When we were talking about put some entertainment in there, that was entertainment, besides a wonderful idea.
I hope I didn't erase the memory from all the presentations.
Lukas, to give all the presenters the opportunity to sit, can I ask you to not sit and stay here, because then you still have a mic and we do the Q&A, and you just do it from here. Fine. And wear your glasses, it's okay.
Oh, I will stay like this.
Thank you, Lukas.
Yeah, wonderful, and thanks, friends, for putting all the questions in the Q&A session. We had PVD coating, we had a refinery casting topic from Thomas and Maya. We talked about selective coin plating, and We have seen a wonderful new product of the polystatement. Wonderful top. Would you ask the first question?
Yeah, why not? To the Bull Mint, from which material are you casting? Sorry, now it's number 2. I will start again. From which material are you casting forms made of to resist the 1250 degrees of the gold melt?
So thank you for the question, whoever it was. Yes, the question is reasonable to ask for the temperature resistance. So in that case, we are using graphite, pure graphite, which is named by our sub-supplier Isotropic Graphite G347. If you need more information, just come to us later on and we share the information with you.
Thanks, Thomas. We have the next one for Germania Mint. What are the components of your metal collar? Is it a mixture of different metal powders?
Thank you for the question. No, it's not a mixture. For silvering, it's only nanoparticles of silver, the binders, the sintering agent, and some other magic.
Thank you.
Thank you. Next one to the Bull Mint. How do you assure cleanliness during casting so that the 999.9 gold is not polluted during the casting process?
Again, thank you for the question. And as I mentioned during my presentation, you have several methods of casting, always dedicated to the target you have, such like mass production under efficiency, so it's a regular continuous casting. But coming to the question of 9999, then the vacuum casting is the method of your choice.
Thanks. We have the next one from Shenali, also for Maya and Thomas. Would you please elaborate the safety measures of your Aqua Regia process at the elevated temperatures? How often may you see NOx alarming? Thanks.
Hi, thank you for the question. As I was explaining, all kind of emissions and the fumes coming from every process, chemical process which is connected to the refining system is going through a system, scrubber systems, which are filled with alkaline solution with a higher pH, which is needed for the nitric oxides to pass through, so it can go through environment in form super pure that is not harming the environment anyhow. Also, these kind of systems are full of sensors, and if there is any kind of problem, it should be dissolved right away. So that's it.
Thanks, Maya. Lukas, next one. Well done. How many such coins have you made? Xin Yao wants to know.
To be honest, we have just few samples now, but the whole production is going to be soon.
Thank you, Lukas. The next question is for Germania Mint again. How is prevented that the metal ink sticks to the coin surface before the sintering? Are there adhesives in the ink?
No, thank you for the question. The first phase before the sintering, it's stick together by the binders. So this is enough for this first time after the printing.
Thank you very much, Simon and Jakob. I'm going to read the next one, but you don't have to answer because you already did that. Great news process. From Patrick, actually, this question, how well is the bond between the base material versus the metallic deposit? But I think you've just answered that.
Okay. After the sintering, we have similar bonds that the galvanic layer.
Yeah. Can you say that again, Jakob? Acoustically, I've not understood.
Okay. After the sintering process, the layer of the metal, it's basically the same stick that galvanic layer.
Ah, okay. Thank you. Dieter?
Hi, Lynn. We haven't heard you on so far in this round of the Q&A session. would it be possible to upgrade the existing tier coating systems to coat the graphite coating? If so, what needs to be changed?
Yes, definitely. Definitely. Yeah, this is the reason we stick our carbon coating in the traditional way. It's just need to change the magnetron, because the magnetron is a different design. So the magnetic field is a little bit weak, so we can do this straight away. We have products that are already ready for your upgrade.
Thank you. Alan, the next one is also for you. Can the graphite coating be decoated and reapplied the same coating if needed?
Yes, you can. Basically, the principle is the same. Actually, it's easy to decoat it because it's called carbon coating. It's a simple element. It's removed very quickly.
For Sonia, the presentation of the Portuguese mint, could the middle layer of the insert in this case be also metal?
Thank you for the question. Yes, more difficult, but yes, it is possible.
Short answer, thank you. Good.
And Sonia, you just take the next one as well. Which is the mintage of these artistic coins?
Sorry, I didn't understand the question.
The mintage means how much, what is the quantity you have been minting of those coins?
4,000.
Thank you. Clear answer.
Katarina, what a cool product. Which challenges did you master until the coin thickness and the insert thickness match after coining?
There were so many challenges in this coin.
You mean this is not a short answer?
We had to choose an appropriate polymer. We tried different materials because we had to use recycled material, which is harder, and we had to try different types of polymers and to find one that would be suitable for to adapt to the silver. What problems did we have? In the first tests, the polymer sometimes bent. It made a curve. What else? Basically this, because the polymer must be soft enough to adjust to the metal. If not, it would bend, and that was the harder path that we had to do. Choose the polymer and then study a lot of the parameters, and the cut of the blank was really, really important. And the edges also, to be able to have a product that wouldn't bend, and it has to be well fixed. If not, we can just remove the polymer. We couldn't do that and couldn't have that. So many problems during this project to overcome.
Challenges, Sonia, challenges.
This happens to innovation managers. The next two ones I will take into one pot because they are comments. Lukas, are you showing anything new this year? Because I can't remember, so erasing did work. And Vladimir is asking, can we ask you a question about a presentation after you have erased our memories? Not possible. So
just call your colleagues and let's do it once again.
So business is just fading away. Thank you. Are you taking the next one, Dieter?
I'm just looking which one is the next one. It's again for Sonia, isn't it? Sonia, have you pressed the groove or something similar into the surfaces of the cutout to ensure a tight fit between coin and insert? How was the resistance force?
No, we didn't need that. We had to have a surface a little higher to avoid damage the surface of the polymer, but no need to use a groove, no.
Thanks, Sonia. Michael Rybacek is asking a question. No, was first a comment. I think Elon Musk needs your help about his rocket project. Semi-funny, we will see. Now my question, what for weight has this metal MP1766?
It's 7 ounces. I mean the silver itself.
Yep.
And plus magnet inside, it will be around 300 grams.
Yeah. Thanks for your question, Michael.
And thanks for the answer, Lukas. Sonia, the two of us are really in a dialogue here in the Q&A session. Again, for you, what is a cool product? Which challenges the challenges we had already, yeah? In the coin, didn't we delete that in the thickness and match after coining? Didn't we have that?
No, that's a new one.
That's a new one? Mm-hmm. Perhaps with the same entry. Which challenges did you master until the coin thicknesses and the insert thickness match after coining?
Yeah, Sonia, you basically have answered that in saying there were too many challenges and you've really enjoyed them. Good. Let's go to the next question.
Are you doing that one?
This one?
Yeah, because you're in
Lukas.
with Lukas.
What was the most challenging step in the production process of your secret coin? So someone is remembering what you did. So
I think catching the balance and finding the most proper relations between magnets in the base, magnet in the coin, and the weight and dimension of the coin. Because we did plenty of tests, and many of our spacecrafts crashed. So honestly, it likes to fall down. That's why it's not easy to take this setup correctly in order to keep the coin within the, let's say, electromagnetic tunnel.
Thanks, Lukas. And for Germania Mint, what is the printing speed and how long does the sintering process take?
The printing speed depends on the size of the coin. For example, this coin was about 1 minute printed, but we can put several coins in the row, so the 1 minute is for the whole row. And the sinter process right now is about 1 hour, but we try speed up a little.
Next one is also going to Germania Mint. I like that, Shenyao, because you are asking about the carrier made by the Mint, or is it commercially available ones? And how do you handle the powder? Maybe you can exchange this information about your chemicals you're using for your process. Did you get the question?
Thank you. No, it's not commercially available. We test a lot of commercial inks, silver and gold, but mostly they made for electronic printers. So it's not suitable for us. For now, the particles are made in one of the Polish university, and in this year we try to make it home.
Thank you.
Yeah, it's Heilin again, to your coating. What is the strength of a graphite IC coating, and does it tend to be similar when coining gold or silver?
Yes, the strength of the graphite coating basically is called low friction. It's the key thing. The friction is very low. We tried in other mint, basically the very, very famous mint that they don't let us tell your name. We basically can be using for silver and gold as well.
For a doctor, that was a very short answer, Heilin. Really good.
Keep it simple.
You're well prepared. Thank you very much. Let's go for the very last question then. Dieter.
The very last one?
Yeah.
That is for you. Was it for me?
Okay. Shall I do it?
Yeah.
Also from Shenyao, Lukas, are you also going to provide the magnetic type of packaging to the coin collector?
Yes.
Good. Wonderful.
We missed the last question for Heilin here now. Do you see the drawback regarding the relatively, and this is the very last question now, do you see the drawback regarding the relatively low hardness of graphite IC coating? How does this to be compensated by higher hardness of tool steel?
Yes, this is something I expect you guys could ask. If you see the coating, the hardness is a little bit lower. But if you really harder than steel, this is a balance. We can tweak a little bit harder. For example, I give the hardness 12 to 18 actually similar like our hard coating, chromium nitride, this kind of things. So it's really dependent on, let's say, application. Hardness is not the kind of things we chase for. Actually, I said again, toughness is the key. So don't chase the hardness. The hard, sometimes good things, sometimes bad things. The hardness also means sometimes brittle. So this is why you need a balance. Something you need to try for your coating. This is why I said tailored coating is very important, not the genetic some coatings.
Thank you, Helen.
Thank you.
Lukasz, if you want to take place here.
Why not? Maybe someday.
That was the last Q&A session and of this block and of this session, the last session which we had. And this is a time, of course, to a conclusion of the technical forum, which will be pretty short and quick because we have some other topics we like to mention a little bit more. We had the 15 presentations, we had 11 topics, and I'm sure all that was, all of you found some interesting new innovations and ideas for you, for your company. And you have seen that, and this is very important, that the mint industry needs innovation, and every year we have, Thomas mentioned that already at the beginning, we have so many applications for the technical forum, and that shows that you are really interested in the products. I would like to thank all the presenters, and I would like all thank all the presenters for their good efforts and preparing the presentations, and please give them all a big hand for the good and valid preparations of the technical forum. And I would like to thank you, of course, because the story of success of the technical forum, when we talk about 20 years technical forum, this is not only the presenters presenting innovations, their products, their ideas, it is more or less the interest of the audience. And when we had the technical forums in the last 20 years, and we do the look back, we are today in the auditorium, and we thinking of starting in 2005 in Basel, and are here together now in this area, and we look a little bit back, and I have to be sorry, we have no early pictures of 2004, 2005, because we might not have cell phones available, and all the pictures printed have been not so quickly available, but you have seen not the pictures from Basel, but the first pictures from Berlin in 2007, and you see young Thomas in front, and you see perhaps when we look to the pictures some other people also in a good spirit in preparing, and Albert Beck always had a dream, and the dream came true, of course, when we see young Patrick presenting, and today he has so many friends presenting Wörtli lines and showing Wörtli lines in the movie. Well done. We had a room, and you see Bettina, and you see Martin, and you see Thomas in the background. A lot of people are still active and are still here, but the room got too crowded and we couldn't open the window. We need fresh air. We had coffee in the other areas. So we went to a bigger room where we could handle about 80 to 120 people. But also this was too short, and then we went to a different area, and where we could handle more than 100, 150 people. In 2011, this was the only 2012 session where Thomas was not with us, and Günter Wart showed up and helped as a co-moderator. We had Robbie in the back. And very important, and that is also good for today, we have seen that today via Slido. We always had people standing up asking questions. Yui Chuang, Shenyao Li, Jürgen Hansen, just to mention a few. And of course, we had networking in the coffee breaks. We had purchasing expert from the Spanish Mint asking questions to every presenter. That took us also during the interesting sessions. We had the 10 years jubilee. We had the bigger rooms, the rooms have been always too short, Shenyao asking the questions, and we went bigger in the 12s, and then, of course, we had the idea to prepare the stairs, and it looked different when the room was full. That was high linen, and then we had COVID in between. And when we had COVID, of course, in the year 21 and 22, we have had also these sessions, but in a virtual way. And we also had a good experience there, and we got very well prepared for these. Standing in front of cameras, 3 cameras, and we always look to the wrong camera, but it was good. And last year we started in this area, and I feel you would agree. We are here for the second time. This is an excellent room for the audience. We can handle a lot of people, and we are closer to you, and we highly appreciate it again. Your presence and your activity in the Q&A sessions. And as I said, the story of the success of the Technical Forum is a little bit the moderators. It's for sure all the presenters presenting the ideas and the innovations and giving us a technical backup and details. But it is for sure the audience, it is you, and thank you for coming and showing up today. But before we invite you then for the next topic for the get-together, and we're all looking forward to joining that.
Yeah.
Thomas also has some...
Yeah, this is the last slide. You are 0 slides away from the get-together and from being released from this audience. Today, you have been very patient. You all knew this takes longer as normal. Dieter and I got some presents which we were asked not to share with you, but we have one thing very special going on. Eva, if you want to bring it, and Nele, can I also ask you to come to stage, please? We have something special because the Technical Forum, may I take this? The Technical Forum is not meant to be for Dieter and myself. It's really the audience itself. It's the innovations. It's what you do, what you spend as a time and for the business itself. The Bull Mint, Plamen and Vladimir, thank you very much, has asked us to use this 1 kilogram silver coin and to put that into a battle tonight for, Nele, can you grab this piece of glass? These are called satellites, ceramic satellites, and you are all invited to see Nele at the booth to guess how many there are in. At 9:30 on time, we will have a good guess and somebody taking this coin back home. Thank you very much for the Bull Mint to do so. Thank you. We also learned there are 2 baby ones, which are ounces. So second and third best guess also will be blessed with something. So thank you very much. And I think this is the right time to give a big applause to yourself.
Yes, this is
almost.
Right. I only have one more topic before you give the big applause and before we move over to the Technical Forum. Thomas and myself have to say thanks, of course, for the support here in the background, which is on the sound Marian, and which is on the camera Steve, and the recording Steve and type. And of course, Julia, you did an excellent job over there. You had so many presentations and slides to change and to move. Well done and super mate. Thank you, Julia. Thanks, a very good job. And Thomas, of course, the 2 of us should not forget Nele and Iris, who have been patiently supporting us in preparation of this Technical Forum. We would be helpless without this support and assistance we have, also from our companies and our colleagues at home. Thank you, friends, for joining, for being with us during this Technical Forum. And the party starts now in the Convention Center. We do the pre-opening of the technical conference. Have a glass of beer, have a glass of wine, have some food and have some drinks, and make the right guess that you are perhaps the winner, which will be announced at 9:30.
Exactly at 9:30.
9:30. Okay.
On the spot.
You need to be present.
And the important thing is, you have to make a guess, and you have to be there at 9:30. Yeah, it's not that.
Don't go to the toilet at 9:30.
And you will be free afterwards, but you should be there because we want to hand it over personally. Thank you,
buddy. Thank you.